Fixerbot says.
Welcome. Stream starts in 5 minutes.
Fixerbot says.
T-4 minutes.
Welcome to my stream, where knowledge reigns supreme. Calm and collected, I'm about to go live, you know what I mean. Got high expectations, gonna teach you something new. Learning, hacking, exploring, there's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland.
Bagus now start. I'm like, what? It's not streamer, it's streamer, but it's not? What? Yeah, maybe we should cut this shorter, but I'm doing ads, right? So we don't have to do them later. Hopefully.
Welcome to my stream, where knowledge reigns supreme. Calm and collected, I'm about to go live, you know what I mean. Got high expectations, gonna teach you something new. Learning, hacking, exploring, there's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unravel secrets, all unlock the code. No limits, no boundaries, all knowledge will explode. Welcome to my stream, where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow.
Stream about to start. 1 minute left.
I'm like, I didn't see it. Will there be more music? No? Welcome in. So I was gonna start stream at 13 was my plan, kinda. But I also knew that I would probably work until 13. But I ended up working until after 14, so then when I got home I was like, oh, Neil stream. Cyber security. So I kinda checked that out too. But I had some other stuff to do too, so doing it well. I've actually been starting stuff up. So we're ready to go, and today we're not going to use mousepad, but code instead, right? So this is what we started checking out on pwntools last time. Yeah, so we just found this sheet yesterday too.
Tyrone says.
Hi.
Okay. Afternoon, fix it.
Afternoon. Yeah. So where we're currently at, I just opened the first one to check the last few minutes before stream started. We have been looking at kind of these things, and I was thinking like, well, we can do this without
Happy Friday.
Yeah, and have a great weekend after today. So usually I don't stream in the weekends, but we'll see how long it will be today. We're really doing this box, but I don't want to finish it before I know all the things about this, because I want to use pwntools. And we kind of already know most of what we would need, but I noticed that it can even run GDB itself. And right now we have until here. We start reading it this bit of it. So the patching here. I didn't read the first ones very carefully, yes. It's mostly stuff that I'm thinking it's not like we need pwntools for receiving data. But maybe some of the stuff is really cool, and maybe it's in this. So maybe I should just make my own, but it seems like here's the read line and stuff, right? So if you just have a list of all the things, yeah, we'll see. So let's continue here first. Actually, that's a receive thingy. So elf, first we're gonna run the old one. So I pasted yesterday the link here for the new ones. When I first ran it, of course it couldn't run, right? Because we had nothing. So let's run it. This is what we did yesterday with the pwntools. We open an elf, and it will, when we do this, it gives us this information automatically. But then we got the base address, which we can also change in here. On this address we read the first 32 bytes of data just to test stuff out here. Then we got what functions there are in there, and we got the ones without underscores, looped through them, and we disassembled them. So this function is called validate, and it is this address. So that's a validate function. Then we have the main function here too. So yeah. So this is not like R2 nice. It is not that. But it's, I mean, I just run a Python script, right? And it's just giving us this at once. So depending on what we want, this might be enough. But I think R2 is much nicer, right? So let's do the code. Look at the code for this. So we use pwn here. We're not currently using this, so let's comment it out. We just got some messy data when we did e.all. Then we got a lot of information, so I did pprint on it. So here's we get the elf information where we just do elf file name, and then we use this the elf file, to get its address. We can also set its address, And here is where we get the rest of the information. E-read 32 bytes from e-address, which is the start address here, right? And we use its function hex dump to get this nice hex output here. And this one's colors too. So we can see the elf at the start of the file here in 7F. Right, so, and this is also the second buffer overflow we're doing in this box. So, interesting stuff. Actually, let's hop to the notes. Because I did actually disassemble them. So, we're making notes on seed binaries, on pwntools and Python, and on here I just pulled these up before. So this is a disassembled the assembler code we saw. Decompiled. Disassembled. Yeah, that's not what I would say. Int main, and it's not much of interest there except for running the validate function. The paused and failed. It just depends on if there's an F in the string. So we get the input straight in here, and here it is copied to a buff that has only 100 characters. So this is kind of obvious. This also is a seed binary on the box, like we're currently doing here, brainpan. So I'm just pausing this box really to do this learning of pwntools. So it seems so cool, and the more I read and learn here, I'm like more and more impressed. So next is patching elf files. So we'll have to read on and see. So we don't, save. This, we don't want to use the same name. And they're using bash too, so they really don't want to say bash. Especially if they're using bash. So, how are you, Tyrone? Look, how are you today? Hope everything's great. So, we import star from pwn. Open the elf bin bash. And I'm gonna zoom this. Why didn't I do that last time? I don't know. Then we have cause a debug break on the exit command. E as some E symbols, exit built in. That we can just put a break on stuff. Disassemble. Oh, and just print it out instead. E. Bash license. Yeah, so we never looked into bash as their example as we were looking at the other one. So maybe I should just use their examples here. E-pack, E-got, E-put. So this needs to be explained. I need more information exactly what all the bits do. Let's copy the code, right? And let's make a new file. So it's quite nice to have this code up instead of mousepad that I've been using so far. I will only use this for other stuff in Python. So alpha patch, yeah, and it's pwn example .py, and let's put this here. So it's going to put it locally, but I'm curious about this is the reason why I opened it up here, because I want to see what their explanation is. Assemble the specified instructions and insert them into the elf at the specified address. This modifies the elf in place. Yeah. Cool. I'm glad I didn't hop down here to start. So let's actually start from the very top. Ooh. Encapsulate information about the elf file. Encapsulate. So I think it's very odd that it's the same thing to connect to the bin bash or the file, and also print information out. I would assume them to be different, right? They are not doing it that way. That's the only negative thing I have to say about this so far. So, ASM address assembly. So, assembles those specified instructions and inserts them into the elf at the specified address. Insert. This modifies the elf in place. The resulting binary can be saved with elf.save. And that's the folder name only there. So, symbols. This doesn't tell us much. But we already did symbols, and that's what I thought it was all, but it's actually symbols. If we look a bit up, or a lot up, right here. No? Oh, they were just talking about it, and I made code from this, right? So we printed all of these with pprint, and that output is long gone. We can do it again, but I don't see a reason. Because the normal functions are in here, right? And that's what I was going for this executable. We're still focusing mostly on the one we're doing, right? But we still want to learn, at least take a glance at what's possible. So we're not gonna modify it really or anything like that now. So, and my kid's starting playing tabs. My cough I got wet eyes. That's all. Or whatever. So yeah. I want a more detailed explanation of all the functionality here. And it doesn't give it. Let's check this cheat sheet, and if it doesn't give it, I'm gonna ChatGPT this. So So we know what asynap does, right? It will give us a symbol for nap. And now we're using e dot. So will this person also use that? There's more instances of asm, so it's nice. So they're not currently using that at all in their cheat sheet. So we're gonna shut TBD. And we're gonna paste. And let's add like please. Please explain detail. So from pwntools, toolkit for exploit development. It modifies ELF binary book the bin by to introduce custom behaviors, demonstrating binary manipulation. Here's a detailed explanation. Yeah, we don't need that explained that in detail. Let's say something more here. The ELF the ELF class parses the binary, allowing access to its symbols. GOT, global offset table, and PLT. So here we have what GOT and PLT is. Too. Procedural linkage table and global offset table. And other internals. Inserting a debug breakpoint. Yeah. But I want to know more, so let's hope it's detailed enough. E symbols exit built-in retrieves the asset address of the exit built-in function in the binary. This function handles the exit command in the shell. In 3 and exit 6, assembly instruction that triggers a breakpoint, commonly used for debugging. When the exit command is executed, the modified binary will pause execution for debugging. So, I would have liked it even more detailed, because we understand that this is what it did, but I don't know what... how would we find this, for example, right? But I guess if we were to run the previous example, let's actually do it. Well, it's not in their example. Let's make a new one from this on bash. So we're gonna make like a checking bash out thingy. We can actually put it in this file, so we don't have to make a new one. So let's copy the pprint line. I don't know why I'm starting to... Oh, that's what I did to get the tears. My god, I'm not tired. Well. So E symbols. Here. List all known symbols. So we want to do this now. For this one. Actually, let's do all of them. So... I thought it wasn't worth copying for those 3 letters, right? By the way, if we do the dots, no, nothing popping up. Yeah, it was just slow. So here we can see all the stuff. That's so nice to have code. So why did I use mouse pad for this? I don't know. I don't know, why do I keep doing that? I'm not falling asleep. My god, it's black outside though. Maybe we should pull the turned down, though it's black too. Should put a sunlight on there. Yes, I want to know all the things. All the things. Let's start typing and actually continue, right? So, functions. So I am the most interested in functions. Did I keep any of the p-prints as a comment? No, I didn't. But let's e dot whatever, we already have it, right? Right, this is supposed to be e, so why did I copy the elf? Oh gosh. This is why I don't like it. When I'm typing, you know, I have to keep pressing escape to not... If I'm going down now, oopsie, I was just wanting to go to the next line. So... let's be proficient. Don't confuse Control C and Control V, right? Let's print a little line there, so we can separate the information. This will also do the rest. Yeah, I'm kind of doing an exit here until we know what we're talking about. So, I'm not F5ing, I'm running it here. So, we'll have to chmod. And we don't have to, but then I don't have to type Python. I misspelled elf. Okay, well let's fix the name of it. Pwn EFL to Pwn EFL and elf and so too many arguments. Oh yeah, it's we didn't put the shebang there, so it's patch example. So it's trying to run this just as a shell script and it doesn't work. Nah, I'm lazy. Well, let's update this, right? So as it was the 23rd yesterday. I was meaning to do Control S. Apparently I cut it instead. So yeah, this is why we p-printed. And to make it easy to copy paste, I'm just gonna add another print in between all of them. Right, let's actually make this a there. I'm like, what am I doing? There. Symbols, God, guilty. So if we're gonna save this, which we might as well, right? Let's use ChatGPT's nice names. But I did not know. Can it now? I was thinking, will it realize that / N is a separate character? Yeah, so sometimes I realize why I don't use code all the time. Because if you have simple stuff and you're not exploring something new like I'm doing now, it is very annoying for it to keep popping up these things. It's so annoying. I need to be able to set the time for this, for being less. It's almost instant. So, one, is it like a 10th of a second or something? It's not long. Oh, so let's see. This is what we had. Now we're gonna get this instead. So, didn't I add \n too? Oh, this is just a function. Yeah, of course. It's bash after all, right? Now we're further up. So, it's my fault. So we're on got. At least this wall of text is easy to find. So, here we have the start of the program. So, I should have cleared first. So we can see this one has canaries. And pynx enabled, fortify enabled. Very different from our little meant to be buffer overflow one. Then we have the symbols, our little header there. And can you hear my kids? They're playing tabs. I can close the door. I'll do that. So I am trying to reorganize this. I can get to the door. I put some bins from the wardrobe in here yesterday when I was cleaning. Almost done. I sorted. I had like a million tiny boxes with screws, and then I had 2 nice IKEA mini shelves with tiny wooden drawers, and in them I had like a bit of random stuff like, oh, these are kind of tiny screws. These are like medium screws, and then I had so many more screws in just a big. So I just poured those into the other screws. And then I had a lot of nice things, and we have. So now, instead of going through all the tiny boxes, like, oh, what kind of screws? Oh, I want 4mm wide, 30mm long screws. I just. There they are. It's so nice. Instead of having to. Very, very nice. So now I can't hear my kids anymore. But I love to hear them being happy. Get an mem copy. Makes all stuff here. Outlook stuff. So these are. So what I'm looking for is really the end of this now, but I guess it'll be far, but we can use. I will have to do this. EFG. Yeah. So this is the first list with all the symbols. So this is just a memory location of all of these. And then when we see them separately, yeah. And there's my new line before the new header. Global offset table. So this list is not as long. So I'm very curious to the exact meaning of these, because I have no idea. More than what I can figure out from the names. So what I have learned of this is just from poking around in the files. No theoretic stuff. So we see all the the normal like library functions. Straight copy. So it's the difference between the top list and this list is like what it's using. I assume not. So my fingers are getting tired from pulling shift here. So here's the procedural linkage table. So then we have the actual functions, and compared, if we look at here's where the little thing is, compared to the other stuff, but this is a big thing, it's bash, it has lots of functions. So let's just, I'm hopping pages down. So here's where the functions without underscore start. There's start. So absolute path making. So we don't want to read all the functions in bash, but I'm just curious a bit about naming and stuff, since exit built-in is the one, right? So let's find exit built-in. So we know a bit here. So this is a function that we're putting a breakpoint on. And we can also see that all of these are in the executable in bash. So can we open several files into this? Why is it saying the file? Oh. So we have the address and we have the size, just as we did yesterday for our functions. And that we had at the very top. I'm not going to scroll up again. So, a lot of... Now I have to check. Just find. I saw find. Lots of finds. Find out. Find file. Find function. Get stuff. Hash. History. Initialize. And init. And internal list. Make. Open. Print. Read. RL. Run set sh. Yeah, I'm not gonna read it all. So maybe we shouldn't print that, right? Again. So let's hop back to the code and actually comment out this section. And now I'm almost thinking. So I don't have the right keyboard for this. Out? Yeah, it did hop up. Why didn't it work first? So we can toggle. Oh, shift control. Look. On Windows, I can't do this because there's characters that I can't click. So toggle block comment. Well, it shouldn't work here, but let's try it. Control Shift A. Nah, we're still in the menu. So now, yeah, I thought so. I don't want that. So let's do line comment. Is this with Control Shift 7? Why 7? Is it like American keyboard? Do you have this character there? For me, it's on 3. Maybe. Oh well. It's probably C comments. That's origin. Okay, I got it. I get it. That's good. Only for other languages it gets a bit off. We can really remove those. So now we know that exit built-in is a function in Bash. Right? So let's make a comment. As a breakpoint, int 3. Oh, I missed a character. Int 3 is an ASM instruction. Whoa. For this, I say, well, I'm gonna say before. I am always annoyed at people saying breakpoints are on something. It can't be, right? They're before. Or like programs saying it, mostly. I'm thinking, should I make a new line? Yeah, it's making spaces of the tabs. Before the function exit built-in. Let's do this to make it obvious it's a function, right? But now when I control S, it didn't change it. But that's probably because I'm not updating the Python looks. Usually stuff you move yourself in code kind of like hops around, right? Especially this line would probably be too long to be considered pretty. Yeah, I haven't added anything here, have I? Testing. Yeah, no extensions added. Oh, maybe something. So they probably did. Yeah, we've no C in this, right? Yeah. I thought it would be on my old VM though. So, now we're to the one that is where I'm like, what? Modify the behavior of shdir. What is shdir? So I don't want to know. I want to know what pack got and the pult is exactly, but I also want to know what shdir. Does it mean change directory? And why would it call it shdir? got shdir fetches the address of the shdir entity in the GOT. The shdir function is responsible for changing the working directory. Yeah, so cd. The PLT puts fetches the address of the puts function in the PLT. Puts is used for printing strings. epack overrides the GOT entry for shdir with the address of puts. The GOT entry. So now we got a bit of more information about GOT here. What GOT actually is. So, we do have the output of the old one. I'm thinking, should we print the GOT list after and before doing this? But it will be so much information, right? So we won't be able to find it really. I want to test and see. I just don't want to do and assume it works, you know? I want to see it done. So, as a result, whenever shdir cd is called, the binary will execute puts instead, likely printing out the directory instead of changing to it. And we could of course run this copy of bash. So it's doing bash modified here. Oh, I'm so sorry for this. I don't know why. Maybe I should go and get something to eat. Though, it's not that far from dinner time. So my kid's sending me Wikipedia stuff. Oh. Life expectancy. Worldometers. List of countries. So, if I start Discord, what will I can do it later. I can click this actually on my phone. I just want to see what he sent. Oh gosh, he sent a lot of stuff. So, got maps here. It hasn't written anything. It's just links. So he sometimes sends me like a YouTube video that's several hours long. So I'm glad it's Wikipedia articles. I can actually read. Let's see here. So GOT means GOT. let's have a look over here. Got fetches the address in got. Fetches address of puts in PLT. So we have to ask, please explain the functionality of got and PLT. So let's continue up here and see if there was anything more. Pack. So pack here is what is doing the overriding. So it overwrites the got position of that there with the address in PLT. So this is like a list of addresses, and this is where the stuff actually are. Let's do the license after we read about this. So, the global offset table and PLT, procedural linkage table, are key components of the dynamic linking process in ELF binaries. They facilitate the resolution. And by the way, I could zoom this. So it's easy to read for people. Facilitate the resolution and invocation of dynamically linked functions. Standard library functions like printf and malloc at runtime. Here's a detailed breakdown of the rules and functionality. Global offset table GOT. The GOT is a table that stores the addresses of external functions or variables used by binaries. Its primary purpose is to enable position-independent code (PIC) by providing a way to reference external symbols without hard-coding their memory addresses. Okay. So that's why. And let's just read about this first. PLT is a table of stubs, small code snippets, used to call external functions. It acts like an intermediate between calling code and the GOT. Okay, so it's not actually the full functions in the libraries, but it's code stubs. So this is what the GOT has an address to, it seems then. Which is not mentioned here. Before resolution, initially, the GOT entries for external functions point to stub code in the PLT. After resolution, when a function is called for the function time for the first time, the dynamic linker resolves its address and updates the corresponding GOT entry. Subsequent call to the function directory uses address, avoiding repeated lookups. Okay, so it's this code bit. It's just getting the address. Now I want to see that code. We can easily now, because we know how, using the pwntools. Enables lazy binding functions are resolved only when they are called, reducing startup times. Facilitate efficient function calls of initial resolution. Supports dynamic linking by allowing the symbol addresses to be patched at runtime. And then we have the stubs. Procedure linkage table stubs, small code snippets used to call external functions. And I think find them is more correct, probably, right? This is ChatGPT text. You never know how much is right. But from what it said in the other place, it's acts as an mediator between calling code and the god. So, how it works, and also about accuracy. I mean, any web page we went into might not have been 100% correct either, depending on what page it was we've been googling. So, first call. So now we see it from the PLT side here. The PLT step transfers control to the dynamic linker via a special PLT entry. The linker resolves the function's address and updates the corresponding GOT entry. Control returns to resolved function. Returns. Well, return isn't the right word, is it? Subsequent calls. The PLT stub directly jumps to the address stored in the GOT, providing the dynamic linker. So, it's the PLT stub that okay. So I thought it went to the GOT first and then went to the PLT. But it's not that way. It's the other way. Between the calling code and the GOT. So the GOT is not filled with correct addresses from the start. Stores addresses of external functions, so variable used by binary. Its primary purpose is to enable position-independent code by providing a way to reference external symbols without hard coding. But it's empty when we start then. Before resolution, initially, the GOT entries are external functions point to the stub code in the PLT. So, here is where I got this backwards, it seems. So GOT points to PLT, but PLT is between the program and GOT. After resolution. So is the PLT even used after the resolution if it's this way? Yeah, so let's Google. I want a human text on this. Yeah, let's do ELF too. Or this one. Someone's notes? Yeah. That wasn't information enough. We got the same. Maybe this. This could be good too, but I only read this. And it says that deal with large portion of dynamic linking. This might just be like a header. Yeah, so let's TTS this article while I go and get something to eat. I'm not screwing. Yeah, I'll just get an ice cream or something. But I'm thinking, if I read all of this, my throat will be unusable later, will it? I could read it all.
ELF Linux executable
Let's
PLT
do
and GOT
this.
tables. Mohammed Al-Yuri. Cloud Security Architect at Fortinet Consulting Services. Introduction. In this article I will explain the basics of the procedure linkage table and global offset table that are part of Linux executable linkage format files. These two are very important in understanding how linking and execution happens under the hood of Linux operating system. It is recommended to read the buffer overflow article as it makes it easier to understand machine code, assembly instruction, and the actual view of a computer program. A look back into basics. If you have ever written a simple C program before, you for sure came across the use of libraries. Who does not remember the famous printf function? It was as simple as that you have given the function a parameter and when the program is executed it was printed on the screen. The deal here is that you do not need to worry on the implementation of the printf function. And how does it do that? It is available for you as part of a library that your program is using. Let us have a look at the program we will be using during this article. Hashtag includes do.h. Int main. Printf, hello world, \n. Return 0. The above code is just a simple program that prints the text hello world to the screen. Now let us compile and run the program. GCC was used to compile the file into an executable and M32 option was used to compile it as a 32-bit executable. Finally the output file was given the name main. Using the file utility we can see that this is a 32-bit ELF executable for Linux and that it was dynamically linked. We will get to know the meaning of this later in this article. A library is a code that is exposed to be used by other programs running on the system. It allows for modular development of code, separation of components and software reuse, which is one of the benefits of using libraries. You do not need to worry about the printf function implementation each time you write a program, simply you can just use a library. For now let us look what libraries are being used by our executable. The LDD command was used to find the libraries our executable is using. One of these libraries is libc, which contains the implementation of the printf and many other useful functions. Keep in mind that we write programs in high-level languages such as C and then we compile programs into a machine code format that the CPU understands. Let us look at the main executable machine code. Hashtag command used to produce the dump. Hashtag objjdump d main m intel grep main a20. Decode m, use Intel syntax for assembly language. The second column is the machine code of the main function, to the right is the assembly instructions equivalent to these opcodes. You can see from this output that the compiler replaced printf function with puts function, which is another function that does the same job, print something out to the screen. The call instruction goes to the address 0x80482E0. What is there? How did the compiler figured out this address? Before wrapping up this section, let us talk a bit about linking. One of the main tasks for a linker is to make the code of library functions, e.g. printf, scanf, sqrt, available for your program. A linker can accomplish this task in two ways. 1. By copying the code of the library function to your object code machine code. That is static linking. 2. By making some arrangements so that the complete code of library functions is not copied, but made available at runtime. That is dynamic linking. Static linking is the result of the linker making a copy of all used library functions to the executable file. Dynamic linking does not require the code to be copied, it is done by just placing the name of the library in the binary file. Linking happens when the program is run, when both the binary file and the library are in memory. Static linking. It is when you link your application to another library at compile time, the library code is part of your application. The primary advantage of static linking is the speed. 1. There will be no symbol, a program entity, resolution at runtime. 2. Every piece of the library is part of the binary image, executable. Once everything is bundled into your application, you do not have to worry that the system will have the right library and version available. Static linking creates large binary files that utilize disk space and main memory. Once the library is linked and the program is created, you have no way of changing any of the library code without rebuilding the whole program. Dynamic linking. 1. Dynamic linking defers much of the linking process until a program starts running, performs the linking process on the fly as programs are executed in the system. 2. Libraries are loaded into memory by programs when they start. 3. During compilation of the library, the machine code is stored on your machine. 4. When you recompile a program that uses this library, only the new code in the program is compiled. 5. Does not recompile the library into the executable file like in static linking. 6. The main reason for using dynamic linking of libraries is to free your software from the need to recompile with each new release of library. 7. Dynamic linking is the more modern approach, and has the advantage of much smaller executable size. 8. Dynamic linking helps overall performance in two ways. 1. It saves on disk and virtual memory. 2. Libraries are only mapped into the process when needed. All executable dynamically linked to a particular library share a single copy of the library at runtime. Ensure that libraries mapped into memory are shared by all processes using them. PLT and GOT. PLT and GOT are part of the Linux ELF file format that is used for Linux executable. I like to repeat this part here as I feel it has the good part of the entire story. Programming starts with having a clever idea, and writing source code in a programming language of your choice, for example C, and saving the source code in a file. With the help of an adequate compiler, for example GCC, your source code is translated into object code, first. Eventually, the linker translates the object code into a binary file that links the object code with the referenced libraries. This file contains the single instructions as machine code that are understood by the CPU, and are executed as soon the compiled program is run. As these two are part of the ELF file, here is a diagram for the general structure of an ELF file. You will find more details on this in the buffer overflow article. If you have no idea what an ELF file is, just think about as the program image on disk that the operating system will use to run the program, start the process. It has the program data and code and much more. Procedure linkage table is a read-only table in ELF file that stores all necessary symbols that need a resolution out printf or puts function. Keep in mind that this resolution happens when a call to the function is performed. It will invoke the dynamic linker to resolve the address of the requested function at runtime. Global offset table is a writable memory that is used to store pointers to the functions resolved. Once the dynamic linker resolves a function, then it will update GOT to have that entry read for usage. Let us look at these two inside GDB for our main function. Start GDB, disassemble main and set up a breakpoint at the call to puts GDB is GNU debugger that is used on Linux. The above command displays the entries in the GOT table. In the call to
Madam
puts we see that we
Fabulous
are jumping to
says.
the address 0x8042E0, but from the above command
Translated
we see
from
that puts entry is
Vietnamese.
at 0x804000C. So what is that address? We can see that the instruction at 0x8042E0 is a jump to the value stored at the memory address 0x804000C, that is the GOT entry. Now let us read the value stored at that address so we have an idea where the flow will go. We can see the value is 0x80482E6, which is just 6 bytes under the JMP instruction, so the GOT pointer value is sending us back to PLT. The pointer is sending us back to PLT, which is normal as this is the first time the puts function is being invoked. PLT now will invoke the dynamic linker to resolve puts function address. Let us place a breakpoint after the call to the puts function and look at the pointers again. Run the program until you reach the new breakpoint. We can see now GOT is pointing to a new address that is in a different range out of PLT. Let us examine what is inside that address. We can see now that we are inside the actual puts function code after the address has been resolved by the dynamic linker.
So I got some more stuff to do, but getting myself food. My kid wanted something too. So I missed, like, except for the start. So, good morning, Cyberning. Welcome back in. So I'm sorry for just leaving you guys here. So I heard this far, and about copying with static linking, copying the code. But what I'm curious about is how the PLT and GOT works together, right? I don't think I was this far along, was I? Uh, so I got pancakes for my kid in the microwave. At PLT. The second column is the machine code of, for wrapping up this section. Yeah, this is what I was talking about. Static and dynamic. Static linking, dynamic linking. So I think this is probably where somewhere here my kid started talking to me in Swedish, and he usually doesn't. I was like, ooh, he speaks English. So dynamic linking differs. Yeah, on the fly, loading to memory, doing compilation. You recompile using the library. Load new code in the program is compiled, not recompile the library. Main reason for using dynamic linking is libraries. Read software for need to recompile. Yeah, the libraries can be like new versions and stuff. Saves on disk and memory. Yeah, so, but it doesn't say how it works. I guess that's where this is what I was looking for, right? PLT and GOT are part of the Linux L file format that is used for Linux executables. I'd like to repeat the part here that I feel has the good part of the entire story. Programming starts with a clever idea of writing source code and program lines of the choice, for example C, and saving the source code in a file. With the help of an adequate compiler like GCC, the source code is translated into object code first. Eventually, the linker translates the object code into binary file. It links the object code with the reference libraries. This file contains a single instruction as machine code that are understood by the CPU and are executed as soon as the compiled program is run. So, why did I need to read that? As these two are part of the L file, I really hope it will go somewhere. Here is a diagram of the general structure of an L file. So L header program header table, text, row data, data, section header table. Okay. You will find more details on this in the buffer overflow article. So the same person made another article. If you have no idea what an ALF file is, just think about it as a program image on disk that the operating system will use to run the program. Start the process. It has the program data and code and much more. Procedural linkage table is a read-only table in ALF. Stores all necessary symbols. Yes, I need to go and get the pancakes. I'm here. 2 minutes, I guess. So, yeah, I need to continue the cleaning today, cause I'm like stepping around boxes that I pulled out of the wardrobe yesterday. Well, early morning. I cleaned until 2, I think. Like reorganizing stuff. Procedural linkage table. It's a read-only table in ELF file that stores all necessary symbols. So here we're actually at where what's interesting, but it's program header table, section header table. So these I've heard about, of course. I need to know more about this. Procedure linkage table is a read-only table in ELF files that store all necessary symbols that need a resolution. Well, like library functions. Keep in mind that this resolution happens when the call to a function is performed. It will invoke the dynamic linker and resolve the address of the requested function at runtime. Yeah, but I want to know which detail. I wanted the details. Global of the table is a writable memory that is used to store pointers to the functions resolved. Once the dynamic linker resolves a function, then it will update GOT to have the entry ready for usage. There's lots of odd spelling bugs. Let us look at these two inside GDB for our main function. So, procedure linkage table is a read-only table. Here you can see the @PLT here. I've never seen that before. The above command displays the entries in the GOT table. In the call to puts, you see that we're jumping to the address, but from the above command, we see that the puts entry is. So this is just forwarding. Sorry that I'm not reading. I'll do this instead.
The above command displays the entries in the GOT table. In the call to puts we see that we are jumping to the address 0x8042E0, but from the above command we see that puts entry is at 0x804000C. So what is that address? No alt text provided for this image. We can see that the instruction at 0x8042E0 is a jump to the value stored at the memory address 0x804000C, that is the GOT entry. Now let us read the value stored at that address so we have an idea where the flow will go. No alt text provided for this image. We can see the value is 0x80482E6, which is just 6 bytes under the JMP instruction, so the GOT pointer value is sending us back to PLT. The pointer is sending us back to PLT, which is normal as this is the first time the puts function is being invoked. PLT now will invoke the dynamic linker to resolve puts function address. Let us place a breakpoint after the call to the puts function and look at the pointers again.
So that's why I was not sure if it started at the one end or the other, because they're going like back and forth a bit. So we can see Naugot is pointing to a new address that is a different range out of PLT. So it still goes to PLT then. So 2E0. So this and this. Am I blind? They look exactly the same. They might have messed up or what? Oh, yeah, so they're looking here. Okay, okay. So let's see what that is now then. And then I have to eat my ice cream before it melts. So this is what I'm supposed to look at. Totally off from the other. So yeah, here it's almost the same as this one. And now it's totally somewhere else. I'm just, it's not like it's saying this is PLT, this is G got, right? So this was my last ice cream, and I don't think I'll buy new for a bit. So I will have a function start. So the purpose I got stuff to eat because I was yawning like crazy. Let's see if this helps. Get some sugar. And food. This was good. But maybe we should actually explore this ourselves. So he mentioned another article. working in IT for more than 10 years. I don't know how many years I should say. So you shouldn't say more than that, right? Are you revealing your age too early? So I was looking for articles. So is there a link? Because it talked about, that's just an underline, no link. Well, these are just underlines. I want a link for the other article that's mentioned. Buffer overflow, right? So can't you just see articles a person has made here? I want more information, but I'm also thinking it's a good, and not a lot of things on this, I think. So where do I see? We can also connect. I like this text, so, but I don't pay, so I can't send notes. Featured. Okay, that's some premium thingy. I'm just looking for the articles. Please show me the articles. Publications. That's publications, not articles. So I guess we search for the Google for the name if we really want to see it, right? Let's see what the first one was. This seemed, yeah. So I just want to know how it works, right? But of course we want to buy about ASLR too. Let's put on TTS on this one too, and I'm gonna eat this without
PLT and GOT.
Sound.
The PLT and GOT are sections within an ELF file that deal with a large portion of the dynamic linking. Dynamically linked binaries are more common than statically linked binary in CTFs. The purpose of dynamic linking is that binaries do not have to carry all the code necessary to run within them. This reduces their size substantially. Instead, they rely on system libraries, especially lib, the C standard library, to provide the bulk of the functionality. For example, each ELF file will not carry their own version of puts compiled within it, it will instead dynamically link to the puts of the system it is on. As well as smaller binary sizes, this also means the user can continually upgrade their libraries, instead of having to re-download all the binaries every time a new version comes out. So when it's on a new system, it replaces function calls with hard-coded addresses. Not quite. The problem with this approach is it requires lib to have a constant base address, i.e. be loaded in the same area of memory every time it's run, but remember that ASLR exists. Hence the need for dynamic linking. Due to the way ASLR works, these addresses need to be resolved every time the binary is run. Enter the PLT and GOT. The PLT and GOT. The PLT, procedure linkage table, and GOT, global offset table, work together to perform the linking. When you call puts in C and compile it as an ELF executable, it is not actually puts, instead, it gets compiled as puts at PLT. Check it out in GDB. Why does it do that? Well, as we said, it doesn't know where puts actually is, so it jumps to the PLT entry of puts instead. From here, puts at PLT does some very specific things. 1. If there is a GOT entry for puts, it jumps to the address stored there. 2. If there isn't a GOT entry, it will resolve it and jump there. The GOT is a massive table of addresses. These addresses are the actual locations in memory of the lib functions. Puts at GOT, for example, will contain the address of puts in memory. When the PLT gets called, it reads the GOT address and redirects execution there. If the address is empty, it coordinates with the ld.so, also called the dynamic linker/loader, to get the function address and stores it in the GOT. How is this useful for binary exploitation? Well, there are two key takeaways from the above explanation. 1. Calling the PLT address of a function is equivalent to calling the function itself. 2. The GOT address contains addresses of functions in libc, and the GOT is within the binary. The use of the first point is clear. If we have a PLT entry for a desirable libc function, for example system, we can just redirect execution to its PLT entry and it will be the equivalent of calling system directly, no need to jump into libc. The second point is less obvious, but debatably even more important. As the GOT is part of the binary, it will always be a constant offset away from the base. Therefore, if pi is disabled or you somehow leak the binary base, you know the exact address that contains a libc function's address. If you perhaps have an arbitrary read, it's trivial to leak the real address of the libc function and therefore bypass ASLR. Exploiting an arbitrary read. There are two main ways that I, personally, exploit an arbitrary read. Note that these approaches will cause not only the GOT entry to be returned but everything else until a null byte is reached as well. Due to strings in C being null terminated, make sure you only take the required number of bytes. RET2PLT. A RET2PLT is a common technique that involves calling puts at PLT and passing the GOT entry of puts as a parameter. This causes puts to print out its own address in libc. You then set the return address to the function you are exploiting in order to call it again and enable you to hashtag 32-bit RET2PLT. Payload equals flat. BA asterisk padding. elf.plt puts. elf.symbols main. elf.got puts. Hashtag 64-bit. Payload equals flat. BA asterisk padding. Pop underscore RDI. elf.got puts.
Maybe we shouldn't
elf.plt
TTS
puts.
that.
elf.symbols main. Flat, packs all the values you give it with P32 and P64, depending on context, and concatenates them, meaning you don't have to write the packing functions out all the time. %s format string. This has the same general theory but is useful when you have limited stack space or a ROP chain would alter the stack in such a way to complicate future payloads, for example when stack pivoting. Payload equals P32, elf.got puts, hashtag P64, if 64-bit. Payload plus equals B. Payload plus equals B %3s hashtag the third parameter points at the start of the buffer. Hashtag this part is only relevant if you need to call the function again. Payload equals payload.lgist, 40, BA, number 40 is the offset until you're overwriting the instruction pointer. Payload plus equals P32, elf.symbols main. Hashtag send it off. P.req B, hashtag this is not required. Puts underscore leak equals U32, P.req, 4.
So this was very interesting, and this person's notes I'm gonna read. Okay. So I also have pwntools. Yeah, I like it. Well, if this worked, we'd be happy. Only worked on Windows. Remote. Isn't that easy? Yeah, so we're looking at pwntools. Yeah. Logging. In context. Yeah. So we have those. Packing. Yeah. We're actually looking at the elf bit right now. That's why we ended up there with these. So, yeah, so I'm kind of feeling that me reading a lot of things is not fun for stream, is it? I'm gonna be cold, actually. Thinking of putting on a shirt. More clothes. Yeah, let's just do that. No reason to be cold, right? haven't used this since last time I did on stream. My hair will be so electric on this, right? So I'll definitely be like crazy electric.
How's it going?
I think my hair didn't like. So I usually don't have shirts that I pull over my head, but this is like a fourth wall sample. It's a bit too plasticky here. So as long as you're not dropping food or something, it's too plastic. No, but it's going good. So we're really doing this box here, but as we have a SUID binary and ELF file, and I want to update my notes for better ways to do this, and I've been like pushing learning pwntools a bit forward all the time. I thought, well, why not use it to do the last bit? So even if we like pause for a long bit and learn stuff, it's worth it. So the thing right now is learning pwntools.
Ah, very cool.
So yesterday we looked at this. Now we're looking at the patching here, and I didn't get this command. So I've been reading on GOT and PLT right now. So sorry, it's my hubby.
Fix-It says. Sorry, my hubby's old business partner for over 5 years ago died. Madam Fabulous says.
Less than 3.
Oh, that's a shock. So he's already, but they haven't seen each other for over 5 years. But still, it's very, yeah, that's life. Stuff happens. I think he might have had some heart problems. But it's always, I think I saw him once, like when he was dropping off my hubby or something. So I haven't ever really met him, even. But it's still, heard so much about this person. Anyway, I'm going to order Thai food. That's what we decided before we started talking about that. So I'm gonna go check with my kids, and then I'm gonna go call and order Thai food. And then we'll continue. So I'm gonna order some Thai food. There. It's so odd to have this big thing, but I thought it was a bit cold. Let's see. Let's order some Thai food. I'll just call and see if I remember what to say. What's the food he wants? He should call. Hej! Ska vi se. Jag skulle vilja beställa en sån här stekta nudlar med kyckling.
Vad vill du ha?
Stekta nudlar. Äggnudlar.
Nudlar. Ja, äggnudlar
med kyckling. Yes. Och 2 stycken vokade grönsaker med kyckling.
Vokade grönsaker med kyckling.
Precis.
Ja, får det vara så?
Ja, det blir bra så, tack.
Du kan komma om halvtimme.
Så länge. Okej.
Ja.
Ja, tack så mycket. Det är mycket folk idag. Tack.
Ja, va?
Det är full fart idag.
Va?
Det är många som handlar idag.
Ja.
Ja. Ha det så bra, tack.
Okej, hej på visit.
So she wasn't that good in Swedish. She didn't understand me. Ordering Thai food, So yeah, he'll pick the food up. I'm gonna have to send a message. They said half an hour. I was like, what? They usually say 10-15 minutes, and this was half an hour. I think I should call him because it was like very long. Hej gubben, jag ringer för att hon sa 30 minuter. Jag bara så har ni mycket folk? Vad sa du? Så hon förstår inte svenska. Hon känner bara igen liksom namnen på sakerna. Så jag vet inte om det är 30 minuter eller om hon men hon sa det i alla fall, så du vet. Varför då? Jag håller på att streama. Nej men gubben, jag sitter och jobbar med en sak. Och streamar. Det är 3 rätter, precis. Laban vill ju inte ha någonting. Jag tog... dina heter ju äggnudlar med kyckling. Och jag beställde vokade grönsaker med kyckling till oss. Ja, alltså det kan ju vara fel. Det kan ju vara så att det inte stämmer. Så gå in och betala liksom. Eller så sätter du dig eller går in i Coop lite och kollar om det finns någon god helgmat. Jag vet inte. Jag fattar. Gå in och kolla på ÖB på verktyg. Nej, jag tänkte mest... men spela på mobilen då. Sorry gubben, jag skulle ju, om jag hade varit dig, då hade jag gått in i där butiken efter typ en kvart. Men jag menar, jag litar inte på hennes 30 minuter. Hon förstod inte vad jag sa ens. Ja, precis. Så gå in när de brukar istället, så får vi se. Får du tummarna? Ja, puss. Vi ses sen. Hejdå. So, like the reason I'm calling and not him is that he's like, he doesn't really appreciate sitting in there with people waiting, but I said, well, play a mobile game then. So we'll see. So this is where I was, right? So, figuring out what this actually does and what God is and what PLT is. But now I know God is a list of addresses connected to all the library functions that are used, and it is not filled in from the start, but it is this is a list of code that finds it, right? Well, this is what's used. If this is called OS first, well, I guess it tries to use this address, and it points here, right, until it's filled in. But what ChatGPT said was that it's always going to PLT, and then going to GOT, and that's when I got a bit confused, because it hopped like back and forth there, and I'm like, nah, we can't use ChatGPT for this. We need human text. There was not a lot of hits here, was there? What is different? Maybe that's a good thing. Let's open this one too, because the previous link, this one was great. Really, I want to check through it all. Cause next step in my buffer overflows and stuff, it's to look at more current things, right? So these are just examples, and dumbed down stuff so that you can exploit it. Yeah, so I won't read a lot now. I can read later. I can read in the weekend. But can we have a quick reply to another question here? PLT got, what is different? PLT in RE able segment have trampoline functioning at except 0 have got resolver rank at PT0. Got in RE enable segment just address, which I learned from this post. What? So this is when I'm thinking this can't be their primary language, right? Position independent code in shared libraries, and we realized there's reason for these, the way of finding the addresses. Yeah, this looks nice. Here we have actual text explaining stuff with pretty code example, just not ugly screenshots. Yeah, but I'm not gonna read this now. I'm gonna continue the stuff. And maybe we should actually finish the box today. And then I can continue looking at pwntools. But I don't want to lose the reason for doing it, right? So this didn't help, but we ended up in a good place still. So global offset table. Yeah, there's a wiki too. There's a wiki. There's the wiki. PLD and GOT. The key to code sharing and dynamic libraries. And I want to know the details. That's what I'm looking for most stuff. So now we got something about GOT. Let's make a folder GOT, right? Because what could happen here is my computer could say, oops, that's too much tabs. So let's put this one in there too. And I need to go through and sort. Maybe I'll do that this weekend, but probably I will be sorting physical things and fixing some things here. I'll form a sheet. So I find more stuff the more I scroll there. Let's open the last ones on the first page too, because that one seemed interesting, and maybe the others are, I just don't see it, right? So here we have the program header table and section header table again that I also want to know more about. So I'll read all these. I'll form a cheat sheet. So let's drag it down. VF documentation. So this is the one I thought looked very interesting. What is this? So what is VF? The purpose of this project is a cross-platform library, parse, modify, and abstract LP and mesh zero formats. Well, I can read this later too. So yeah, this is the one we already had. So let's see, is this a duplicate? Here. Right? No? Yeah, I moved there, I think. This might be another one. Let's scroll down and see. Oh, yeah. I think this is a different one. Just very similar layout. I did put it in the links already. So, yeah, right, this was the pwntools cheat sheet. I tried to find it in there. I didn't. Let's see, is this good? Do we want to save this? We're gonna make our own notes, right? But basing it on other people's notes is just smart. But this kind of thing this is too much for me. I don't need that much notes. And here we have unpack, and here's pack. So hopping over here, this is what we use here, pack. And I'm guessing it will put an address and what to put there. Address, what to put there. And this doesn't say that, does it? It's a pack. Function of data, what it will. Yeah, so it doesn't really say what it does here. This is just a list. Right? But we can still use it as a base to build our notes on part of it. Like this, we need to check out this thing, you know. And cyclic, we already did look at, since I had problems with it. So, 4 is the default. Let's change it to 8 here. Okay, so we give it here, of course. So I did learn something here. Poor computer, it's gonna have a million different ones. Well, I'm sorry, but it already has a million different ones. And if we scroll down here, we have years and years and years. And sometimes I sort it. And yeah, I should really go through. I did clean up a lot some time back. But as you can see, it's not finished. I wonder how long I can do this, you know? Yeah. Got lots of stuff here. So I've used Firefox for a few years, let's say that. I didn't start using it yesterday. But sorting and making like trees like this makes it better. And I'm sure, oh well, now I have to scroll back up. I won't do that. So there's like projects and programming and stuff in the top. And this is a motherboard. Never ordered one. So the reason we created this was to put that there. But let's also put these. And that one is not only related to that, I'm proud of my kid. He has much more than me, but he has like so many ones saved. Part of me thinks, well, why don't you just... I'm amazed it changed all the sizes. But it's because it's the same. Let's get up with it. So it's all 140% now, except for this. I really hope my hubby doesn't have to wait for half an hour for the Thai food. So, this is where we are touching. We know now what pack does. I did not write it down. Maybe it's time to put the nose to the next level on this. And actually make notes. This is what we have so far. Alright, I did save this code in here, and I deleted it, so we could have copied this before. Yeah, so my left arm started hurting after I did this. Now it had a bit tight here, so I don't know if it's still odd from my shoulder. Oh, whatever. Let's continue. I'm kind of thinking I'll remove it again, though. It's a bit warm to have all homes done. Yeah, so this is really what we need for this box. We did this yesterday too. So here we have the code. We need user 101, 1001, and a shell for AMD64 Linux SH. Or 32. Oh, we can try this one first. Maybe it's 32. Yeah, I didn't think of that. So we should probably update it again. I didn't list the whole thing. Alright, look, we didn't put this in the right thingy. So i386, that's what that's called. So i386 Linux SH here. That'd be what we do. So what if we do one of those two? Actually, so the binaries are 32-bit, so we probably shouldn't do 64-bit. At least we know 32 will work, right? And this fell asleep, of course. And I'm not hungry. Getting food soon, though, right? Oopsie. Oh, right. Of course, it can't combine. There. So cute when you get lots of errors like this. So here we have our shellcode, right? And we can just use this. And seriously, I probably need all of this and move it over to right. So I actually copied it because I was thinking we want this, really. This is what we want. This is why we're doing this. So we can use shellcraft from here. And so I'm getting lazy. And I'm thinking the day is long. And it's been long. Yeah, we're already in there, weren't we? But I want to have Python examples for it. So I shouldn't have searched on that one. So we're finally in the right place. This is what we want. Let's make a new file and spell it right this time. Let's do. We're using pwn, so I'm adding that first, and because my old fuzzers and exploits and stuff were just normal Python, so now we upgrade in, and instead of just getting shellcode from Venom or Google, now we are using shellcraft to generate it within the script. So we don't have to have this long bits of text in there either. And generate shellcode.py. This is like the example for this, right? I'm gonna grab that. And we're gonna type, or we're gonna copy actually here. And all examples are Python 2. So it keeps adding up another reason to use like basic stuff. Help, shellcraft, and hex. That's a new one for me too. So not F5, but let's and I'll slash pwn and generate. Oh god, I hate this. Why? Can't I just get text? So this help function, did it run man or what? My skin is crawling. I hate this. Help on the function sh. Run. Assembly shellcraft. Run assembly. Run assembly. Run assembly. Run assembly. That's cool. But this is not just on the command prompt, it is in the horribleness of more or less whatever. Man, all those things use this crappy thing that I have big problems with. I want to be able to scroll in my old stuff, it is just gone. It's not there, right? It should be there. So I should grab my nice outfit, but I can't. So I guess I miss a place to put notes. I'm gonna make one. So here's the Python thingy. So I'm actually gonna make a new thing. So let's make a folder instead called Python. And I could call it Python. It worked. That's the basics on this one. And dash it. Because I'm gonna put lots of stuff in that. So now I'm gonna put like just notes. That's the name of the file now. But that's not what I wanted. Let's do it this way. So we can just click a function to see our notes on it. And the example that they had in the help. If I run this again for the very last time, and we grab the whole thingamabadoo. And it just got 19 and opened up this. So what I'm looking forward to in the path there next is after the buffer overflows, we have Active Directory. And this will be fun, and then we'll have other fun stuff here too. So I need to finish this too. But pwntools feels important. Yes, important. I'm gonna do this. And I'm gonna abandon this thing. And hope that we will get something better. Let's get rid of that. And now if we run it, we just have these two. So this is the shellcraft sh. It is code, in other words. Assembler code, normal code. With comments. Yeah. So let's actually use the one we wanted, right? Put it here, did I? No, I didn't put it anywhere, did I? Yeah, it's up here. Thus. Combined with this information. Yeah, here we have shellcraft dot. So, here we have the i386 ones, and then Linux, yeah, Linux. So here's the SH one, and if I click this, then we actually have a run example here with that, exactly the same. Confirming it is shellcraft. Like this. So let's replace this. No. I wanted to see if it pops up anything. It always seems to pop up stuff when I don't want it. Like that. But SH doesn't have anything. Well, I guess we call it code. And we put this. Nah. I'm kind of thinking, can we plus this? Because that's how we do it at the command line. So I'm thinking there's a reason. Shellcraft dot i386 dot Linux dot set UID. And we're gonna put them the other way, of course, otherwise it's crazy stupid. So, will this work, right? I don't care about these lines. But we can see there that we got not very usable format. Now we know what hex does, right? It just makes it hex. That's a long number. It's a digit. So, it doesn't do plus. for function and string. Oh, I forgot the parentheses. There's a doorbell, but I'm guessing my kid's the one it's for. There. Just a sec. So, what would you say about this? Yummy, 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 yummy. So by the way about this, the worst thing is that there's no contrast between the colors. It's like it's all one color. Well, it's purple, so I'll survive. Let's see. Did I open that? Yeah. Just wanna see that. So yeah, I think I'll remove my hoodie. I don't want to eat when I have so much clothes. Yeah, I should never have put it on because of the hair, you know. It gets really electric. So my pants have been falling off all day. I'm fixing this now with the Thai food, right? I hope not. That I will get that much fatter. So it worked, right? We got the output with the comments and everything. And
Born Again says, "Hello, pretty woman."
Hello there, welcome in. So we got some code there. This is much easier to read than the machine code, right? So push sys get a UID. Knock on the door again. Jag fick precis min mat. Jag kommer till dig sen du äter din mat, okej? Jag ger dig Nej, jag skulle säga det är ännu värre här inne. Låt fortsätta stanna klart. Yeah, so I can't hardly walk here because it's I was cleaning yesterday. I put some boxes here. Have to finish. I cleaned until 2 a.m. So then I thought, oh, well, I probably better get some sleep before work, right? Yeah, so it's actually this bit here. This is the... First we have get EUID. Then we have set radio ID, which is what we asked for, right? Yeah. Interesting. So I'm looking at the int 8 zeros, and we have them in the 3 places here. Here is this execve. I have a trouble not reading that in Swedish. Yeah, and this is the bin sh. And lots of other stuff. Do we want to compare this to the other version? Right, let's do it. We're already on the right screen. Just need to hop over here. And let's so I wanted to copy, not paste or whatever happened. So I have so much food. It's so much. And I think that they had like almost all of it is chicken, and I like the veggies. Even though I got my kids veggies too, because he doesn't eat them. I don't have a lot of veggies. So, first of all, we're just gonna change this to AMD64, is it right? Let me scroll up. AMD64 Linux. So it has some bits of code. All of these are just a text string getting a certain text. So there. So I don't like having food between me and the keyboard, and I wasn't very hungry. I also have a few of these. Let's get rid of this. So this is a box of easy adapters. The first one is not here for some reason. So yeah, I'm gonna put my food on the other box there in a sec. I'm not gonna eat that much of this, but I'll eat a bit. So let's run it and compare. I guess we're gonna paste it somewhere, wherever. Well, this is okay. So I'm gonna compare it to the section underneath. So this is identical. Here we have a different different one. This is 3-1. And then we of course have RAX instead of EAX. Right. It's all the registered names. And instead of int 80 hex, we have syscall. So they made a better instruction. And then we have now this is 4-6, but the name is the same. And then we of course have our EAX, another one. And this is ECX, EBX instead of RSI. So there's those kind of differences. Then here we have 6-8 the same, and this will fit within 1 here, right? Because we have 64 instead of 32 bits. So on this screen we can see we have 2 lines to fit the string, bin sh, that's what we want to fit in there. And keyword, pointer, ESP, RSP, there's different comments. It's commented that XORing something with itself makes 0 on this one. It isn't on the other one. ECX, RSI, push 4, push 8. So I'm guessing the function calls use different registers, and that's why. And again, we have a int 80 hex here. So it's not the same, of course, but it's very similar. It's just those things that are changed. It's not like completely different. So we don't want to annex it. We want to asm it though. So what is the output of asm? We will see when we run it. And we actually want to put this in a variable. Shell 1, shell 2, I386, AMD64, this is just a text string, right? Oopsie. How many keys can I miss? So my thingy went out of power. So there. I'm thinking we want to pause here. And that makes us not need this line. So let's do input. Yeah, it works like this. Input, press any key. We can find any key to continue. Where we could even do this, right? Does that look ancient? And we also want to do a print asm and this. Where? And we're not gonna use the hex. MD64. So I have this much food left. A few more bytes, right? This will be 2 more meals for me at least. Okay. Yeah, so I kind of thought so. It's the right format. We don't have to do anything. The first one doesn't have a backslash n x though. J1x. It is not a hex. Okay, so the first characters are not hex. They can be printed. So, you can also see the bin SSH here, or SH. And these are the calls. This is calls. Well, let's do it again. There. Oh, so what did I do? Oh, I didn't write the full name. Of course it can't. There's no variable called that. But it meant something. It was a constant, so I thought it was something odd, probably. Or it would have said, I don't know this variable, right? So, let's run it again. Let's do the second part. So here we have ASM shell 386, and here we have the ASM shell AMD. Let's just comment this line and check that this works, right? So that I didn't do anything else odd. Yeah, so this prints out Okay. Maybe it can't do it. Maybe it's a different function. Maybe there's ASM64. But I think it would see what it is. No? I'm just gonna be stupid and test just to do it, right? Yeah, not defined. Now we have a pretty error that's logical, right? So now we get what error? So run assembler O step 2 step 1 log error ponlib exceptions ponlib exception. There was an error running USR bin x86-64 Linux GNU AS32. Oh. It had an exit code 1. So now we know what it does. So, assembler messages. Operand size mismatch for move. So I still want to see these things now. But let's Google it. We don't have to do it manually, right? So let's pwntools has some 64-bit. Yeah, does pwntools not ASM format like ASM? It's wrong. So yeah, this is what would crash for us. Too many memory reference for move. That's not exactly what we're getting. Oh my goodness. You're attempting to assemble a 64-bit instruction with 32-bit assembly. You need a set. Oh, so this is what we need to do. Yeah, nice. So before we do the 64-bit one, we do this. Actually here. And let's actually do it here too. Let's add the I here because it's just prettiness, right? So then we run it again. Now we get an error at once. What could it possibly be called? 32-bit. Here it's 64-bit. 5386. There could be the problem you can't do them in the same file. It is possible. with context, local arch ID. This is nice. I like the width. Yeah, I like that. Many things can also control via the global variable context, such as the selected target operating system architecture and bitweb. In general, the exploits will start with something like context arch in B64. We set up everything for exploiting a 64-bit and binary. Recommended methods to use to magically set over appropriate values. Challenge item. So, how do we get the context from that after? No, I'm gonna explore this. This is fun. So we're gonna start a new file. Code. Get arch file. This won't be a very good file name for this one. My God, I didn't want to comment any more lines, please. So, get arch. So, context type arch binary bits. Okay, maybe we need to set the bits. So now we can get it. So I wish there was a way to mute this output. I don't want this up, do I? Let's put this in our general elf info. And maybe we'll prettify it a bit more, right? Yeah, we have context stuff here. And before I did it the opposite way. Here was changing the address. But here we're getting it, right? Context binary equals. What do you think? Will it work here too? Yeah, because we will probably do e dot context. Oh, why did I put it so high up? Because I had the other stuff there. So what did I put in here? Right. So So, no errors. So I'm assuming it's printed. No, context type is empty, so we need to run it. Meaning we'll have to get this information twice, which is not pretty. Well, I'm sure there's a way to do around that. Will it have the right type? Can that function, does it have a version that can handle that? No type error. And we get the information. Nice. So we only have one problem. We have two little new lines here. So we need another print because I don't want to mess with auto detecting. And also I don't want the p print. It just p printed. It didn't p print. It p printed, but it didn't p print. I guess we don't need this line. So p print is automatically there. So let's not print it like this. We have arch with binary. So print context dot arch. Bits. Binary we don't need. But OS and ending. Oh right. I wrote bits twice. 1, 2, 3, 4 interesting ones. So let's just put them in the right order. And let's count that one out. And we're gonna put information. So I wrote one first because I was thinking, is this a string in this way? Right? And it worked fine. Better to get an error in one place, right? No, very wrong. Plus. Oh, so there it didn't double it. Bits. And the OS. Bits needs a string. So, architecture, bits, Indianness, OS. Let's fix the order a bit so it's prettier instead. So, OS, architecture, bits, Indianness. And so I noticed that if we put 2 more here, we align with our text. So these are indented. Well. I can't change the format of those. Though I can change the format of base address there. I can do that. How many spaces do we need? Let's actually remove 2 spaces from these because it doesn't look good anyway. So I think architecture and base address are the same length, right? So if you just remove this and put a space in there, and we go 1, 2, 3, 4 pages up, we can see that the base address is now aligned. And yeah. Should we do functions up there too? By the way, this is interesting information. We now know that it's a 32-bit, right? So it's not like for nothing. We know now that we need 32-bit code to put in there, otherwise it will go bananas. Not work very well. Looking at the food, thinking, yeah, I might want a little bit more. So what do you think, guys? You don't have to be quiet. You can talk to. See, there's supposed to be people. It's okay to lark. It's totally okay. But it's always also okay to give me tips or ask questions. Yeah, so if I read all of this, it would take forever. So let's... Every time that I want to do something now, like this in Python, I'm gonna explore if pwn can do it. Yeah. That's kind of the thing. So this works. It's not like it's anything complicated. But we could also use the code from here to make it prettier. And I'm glad this line worked. It was just an experiment. So now we know we don't have to do that. Let's confirm. Oh. So, context was architecture bits links. pprint works without using an import for it. And I think it's nicer looking to put a separate print up there instead of putting a \n in front of the OS. So there. What did I do? Food e-search. Let's make a new line on that, and then let me close this one. Let me go back to our generate shellcode, and now we know that we need context bits to be 32. I'm assuming this, that this is what we need instead of this thing. Right, so let's delete these and just go 32 and 64 and see. But so what? Redo. Yeah, I replaced. So let's put it underneath and comments us because I want to experiment more probably with that. And 64. Will this run now? So generate shellcode. So that's 32 bits, and this still didn't work, right? Invalid architecture combination. 9386 is the default. So that's why we didn't need to set this, but we need to set this. So now we know why, hopefully. As our attribute lower, arch lower. So it's getting stuck on the line we don't need. So I'm gonna comment it and see what works. So we're still getting the same error on the AMD 64. Context arch. So how do I set it? I'm doing it in the wrong way. So I still think of the width, because width is so pretty to keep it contained in a section, right? Ending it without you having to do anything. Like opening a file and it's being closed. Oh my goodness, sorry. Let's hop back to this where we were actually reading, right? Does this have anything on that? Yeah, architecture is in context. In context we did skim through. And this is how it's supposed to be. And I'm kind of sure that's not what I did. And I know what the problem was. So this is supposed to be a string. And I didn't make it string. And that's why they fail. And now Good. So we can get the assembler code, and we can get the machine code. Well, it's actually what we would input to Python that we get, right? If we were to, but it's bytes, meaning this is just one way of outputting it. We could use it. They had, what is it, like Hexify or something? Sounded very. I'm gonna. The reason I split some of this was really only to, well, I guess. Only to split them easily to not make it scroll like crazy. Yeah. Let's continue. So now we have, we know how to, within this, generate the byte, generates machine code in bytes format. So I'm saying bytes format because, not byte format, because that's what the function converting it in Python is called. Output assembler code. I should probably space that. Like, I should have done it before and copied stuff. I don't know. Sometimes it's prettier the other way. I don't know. So now we have done the same thing. Let's output it in this format so we can compare this output with this output, right? I know how to put it, to print it, right? Yeah. So I can just copy what I had in another one. Here. This is hex output. So. No. This will not do it for all of them. So if we look at this, I don't have the loop here. No, it's in bad shards. It's still here. So C for C in all shards, if C not in bad shards. Char I for I in range, yeah. And then I had a print. This makes it bytes, and then when I print all shards, this will be the same kind of output we did. So, as I said, let's find a solution in pwntools, not just generally, right? So, pwntools solution for looking at bytes versus strings, it says here. Encoding and hashing. I'm thinking this is what we want. And let's scroll until we see something looking like this. Pack. So we just run pack. Yeah, we run pack. So to print the thing I want right now, we do pack. So this time we're going to pack to. So for me this feels very wrong because we used pack to update memory. But I guess it will be printed thus. We'll see. Interesting. Let's I'm putting a print in here, not to mess up prints automatic sensing of types. Yeah. Kind of felt this was wrong. A sign is known a number. So it can do this on an address, but it can't do this on something more. Bytes and int. Okay, we can convert the whole long thing to an int, but we can't because it's too big. If we split it up. Let's continue looking. What is P16? Oh, 16. Hex, unpack, hex. Yeah, we don't want any of those. I've done this before, so I'm just mostly interested. So this n hex, that's what it was called. That it makes it hex, right? But this is not what we want. We want the backslash x version of it. We could also hex dump it. If we just instead put the variable and the length of the variable. Yeah, nothing in here. And this was... Are these the same? Context? Oh, okay. Yeah, context. I think we got what we need from that. Let's look at this then. So this will be about bytes and strings. But there might be something flat. Padding. Flat. Okay. This is the format I want. So this will output not this format if it's printable character. What? Was there a difference between these? Flat, print, hex dump, flat, B, padding. Okay. Yeah, so maybe there's nothing in pwntools and I'll have to just normally do it. I'm just curious, you know? And I want to explore this as much as I can. So why do I keep opening these when they're already up? So these examples, well, let's remove that. These examples might have what I want. Wrapper. Nah, it's the same. So I want it all to be \x, not the printable characters to be pretty or printable. So I didn't do any change. The shellcraft module gives you pre-canned assembly. Yeah, so this is what we've been using, and this is the example we started with. And the 3 command line tools for interacting with assembly and shellcraft we used ASM and disasm, and I think I've actually used ASM to find some instructions to search for. I don't remember what though. Architectures. Canned assembly. What do they mean with can? Whatever, they just have this. I want to \x. I think it's nicer and more readable. And this is for no reason at all. This is more only for discovering if there's something in here. Let's read this to debugging. Debug. Oh gosh, this is the cool stuff. Yeah, cool stuff. And more cool stuff. And logging. Warning info. Debug. Context. Log level debug. Oh. I don't understand why people would run Python stuff at Python terminal. If they can just run and rerun it without typing. Yeah. I think I'm gonna log level debug. Context log level debug. So if we run our let's close these that don't have anything to do with this. This one, if we set the context at the very start to be debug, Let's switch since I all my code have these. It looks funny. Context log level, and then we read the context from this. Will this change the debug mode? So let's actually print log level. And let's start with this not set. I'm assuming the default is something else, but we don't even know what it is called. Elf info. Oh, it's an integer. So that means I can't get a new hint on how to do stuff. Log level 20. And now we know 20, right? $10. So equals 20. And default is 10. So no, 10, default is 20. So confirming. No, it is 10, the line is not commented. So did we get more information? We got debugging up now too. So I was mostly curious here, up here. And then we have what it is running here. User bin, Linux GNU, copy, iBinary O. Data code, rename section, data text, and step 2. Step 2 there. Copy. So interesting. Of course, there's similar commands, but here we should have L32I386. X8664. X8664. Oh, it's not correct. It's not right. Let's actually scroll back and see when we last had it correct. So I'm gonna go far up now. Here's when we did with something with these before, is it? Here we have all the stuff. Generate shell code. Generate shell code. Here we have int 80. Int 80. Oh. I'm stupid. I'm thinking of the wrong program. That's why. It's that one is of course all 32 bits. So it's my kid. I'm gonna bring my food down at the same time. I'm gonna fix him some microwave some spaghetti and meat sauce. It'll be kind of quick, but this will go bad if I have it here for long too. So I'll be back soon. Yes, jag har käkat upp nu. So there. Now we can focus again. I kind of felt we're done with one thing, right? So let's continue exploring the different things. All right. Warning for debug. Yeah, I'm not interested in that. But I'm interested in if these are also the levels of if these are like saved as we can set these string values for what is supposed to be an int, right? So it wasn't a constant, was it? It's a string debug that is replaced when we later check it with 10. So yeah, I'm like, we done with this? Local processes, remote TCP and UDP connections, processes running on a remote server over SSH to Port.io. And first, I think this was like the first one, right? So first when I opened this, I was like, yeah, we don't need this, right? This is already available. And then I was like, so let's try doing everything through pwntools. Why not, right? Because someone made this for a reason, and if we're reusing it, it might be good to use all the things so they're connected. I'm thinking it's time to make the main note. And just copying this would be kind of stupid, but just having this bit with links like this, right? So tubes basic IO, and I might change this anytime, really. Receiving data, sending data, manipulating integers. I don't know what. I'm not happy with this. Changing it in once, at least the name of it, right? Now we can tab back and forth. So let's paste this. So all of these are links to within the document. I don't really get why they bunch these up with these instead of the encoding stuff. And even though I don't see the reason for these functions, I still want them mentioned in my notes if I'm listing like all the things. And the process here is very interesting, but it's not even in a list. So we need like examples for this too. the full documentation for more information. Yeah, this is just basic full docs. Now we have processes. New process. Yeah. I guess we start with the ones mentioned here. And so the basics I made is totally different. And we're gonna split this up too. This is for elf, really. And this is for about the hex stump. And read. And we can just delete this. I will never forget that, as I knew it before we started with this. It was called Poem, right? And pprint we didn't even need anymore. Which is interesting, because I needed it on my Kali machine. My Kali laptop. So this is one way to go, but this doesn't say what this does. One way is making example programs here, but we have those over there. And it's mostly for, these are for elves and stuff, so we can't even run them on this machine. Yeah, let's not do it all right now. So let's just put an example here. And feel pleased with that for now, right? So that's mostly receive line. So this is mostly more about, yeah. Reading binary data as a program user, you can receive up to a number of bytes with rest or block. Okay. So yeah, I don't care about that. For now. Yeah, let's not dig into notes more now. There's like an infinite amount of stuff we can do here. Not an infinite amount of functions, but a lot. So many things. Here we have the running and debugging, which is when we're starting to get very interesting. It's starting to be very interesting for this bit here. Let's make a new file again. New file. Phone elf run. .py. Debug, I guess. because that's what's interesting. And let's get the start of it from this one. We could just continue here. But I've called this info, and it's kind of suitable not to have all the information, right? What do you think? This is disassembling the functions. Yeah. Yeah, let's make a new one. But let's grab these things and put it in the other file. So this is just disassembling and showing we can dump a bit of memory, showing the base address, showing the how many bits we have, right? That's grabbing this bit, and we're gonna pop it over there, and we're gonna edit it a bit because we know what OS it is. We don't need these comments. This more belongs to there, and so we have a elf debug now. So we still get the information. We know it's i386, right? The bits. We know it's little endian. We don't care about the log level right now. Also, let's comment that out. So I'm mostly just interested about the number of bits. And the number of bits will prettily fit after this if I do some messing around. There. Bits. So it's time to do something more with this. If you have an elf object, you can run debug. Run or debug it directly. The following are equivalent. So elf.path. Right, so we just gonna do, as we have grabbed some information there, right? Let's try both. Because why not, right? So and this is what we have over here, right? With file name already. Yeah, this is before we read this bit. So now I'm assuming instead of doing process path here, we can do the E. They're just calling it elf lowercase. Why would we do this? Let's just remember it. Fondly delete it. We'll see. So what will this do? Let's run this. We have the debug on, right? No, I turned it off. Starting process. Stopped process. So it has arguments and it stops quite at once. So if we do // validate here, usage validate input, so validate input passed, and if we do F, it will fail. So that's how simple it is. But it has a buffer of 100 characters. So let's crash it too. So there we get a segmentation fault. So, but now we want to run it in here. So how would we use arguments? Similarly, you can launch debugger trivially attached to your ELF. This is super useful when testing shellcode without a need for a C wrapper to load and debug it. Oh. So let's do debug. I guess we copy the things that we're gonna delete a lot from, right? This I wrote this before. Was it yesterday or the day before? We started this. Did we start this yesterday? Was it longer? Yeah, let's comment on it too. Attribute error. Has no attribute debug. Home web elf. Elf. Oh. I forgot to delete the L and F. Of course there's nothing. So here we have the same problem again. We can't see the output anymore. WTF. Why would anyone do that? I so don't get it. So I would like to see this information afterwards, right? So what if we remove or add the debug here? Nothing. So now we get debug information too. So it would be so much easier just to run the debugger normally than this. It poofed away. Poof. And I want to be able to scroll up to all the things. And it's not there. I don't get it. Why? Why on earth would anyone want it to go away? Let's remove that again, because it didn't help. What will help though is to add what we used here to patch it. And exit doesn't exist. But what do we have? I don't know if exit built-in is something that exists. Let's see what error message we get, because this will get an error, right? Because we don't have this function. Sorry. Yeah. So we'll see. Yeah, this won't work, but I'm curious to see what it says, so I'm gonna do it anyway. Key error, exit built-in. And of course this would have to be done before too. We just need to find something else to do. So let's do validate instead then, which is the function that actually does the things. And we run it again. Now it should be a breakpoint there. No? That's a mega fail. Now let's turn on the debugging again. So we hopefully can see a bit of what it does. So in this it doesn't say much. So I so want to go just do this in R2 now. I could let's do it again in front screen, right? So you shouldn't have to do this. So reading symbols from validate. From remote target. Files transfers can be slow. Use this row to access local files. Debug build ID from remote target. Target. I don't get why they close it down. My kids are playing. So the other day, I ate a bit of gingerbread house, and I regretted it. So now I'm just gonna eat a tiny bit. So this was the last of the house. We're eating it all up now. So right, let's close the screenshot down. So far, this has been a total failure. But let's see what it says here. I activated the debug. Oh well, it doesn't tell me much. So is there like an option to make it do the current window, right? So tell me about the debug. Loading. So definitely lots of options. So what does shell false mean, for example? So of course we need arguments, right? So let's give it arguments to start with, and let's disable the debug because that wasn't useful at all. One last look. GDB script 2. Yeah, I think it's harder to see. 1, 2, 3. So with an output, it will not give the debug message or the command line do this. Help. Did it even do that? Alright. It needs to be a list. How do I do that? I'm too tired to not just test it. So, starting, running, stopped. And if I want to see the output, I need to screenshot it. So, where is the output of the command? So I have to do something special to see the output. So I don't see why I would do this, but I want to learn this very much, so... I'm gonna eat these first. So let's see if there's more. I can't scroll down. So, debugging. That was a new one. I was like, that can't be the end of it. Yeah. We are RVs and OCs here. So, in addition to the resources here for debugging, you might want to enhance your GDB experience with one of the following. What's this? Yeah, I don't want to use a special GDB. I'd rather use RTF. So let's make sure, because it keeps talking about remote stuff, right? So I know I have GDB. GDB server. Yeah, I already have it. So how can I unset it? I should have checked just. Launching a process under GDB. Still being able to interact with the process from pwntools is a tricky process, but luckily, it's only sorted out the process is pretty seamless. So it's tricky and seamless. So I kinda wanted this, right? How do I control it? IO interactive. Okay. Before we do anything else, I want to try interactive. Oh. Can I do stuff now? Will it not stop? It's taking a longer time. So I have time to actually type something here now. Nice. So I would have preferred though to not to switch windows. And break start. So I'm assuming we can put this in the other's way of starting it too. So yeah, I need to know more if we're not using gdb.debug. This sucks. It's too sweet. Yeah. Come on, show me what it is. Export. I don't want it to switch windows. I should say terminal instead. Terminal windows I will search for. Debug executable in the this is Visual Studio, so we're so off. I guess we have to say tools. Yeah. Well, let's just continue reading for now. So let's go back here. gdb.debug bin bash. So this is not how we're starting it, right? So I need to know the alternative. But let's say comma gdb script, because they were named, right? So this should work. But what we want to do is to break main, break validate. Can it do that? But we want input to let's put 10 characters. And I'm not touching anything now, but we'll put the interactive in there. Shell number 1. So let's just open a new window here. A new terminal window. Called it shell number 1. I know there were settings for this. There were settings for this too. I'm sure. So it says here, by the way, switch into interactive mode. User bin GDB. Yeah, because it's running GDB. But I just wanted to use it in the same window. This is horrible. It would be easier to start GDB. But assuming we're not actually doing stuff here, but we're doing like switching to interactive mode. And now we have interactive mode here, I guess. That's what we saw before. So yeah, I'm not gonna eat any of that sweet stuff for a bit. I'll just feel sick. I already started a bit. So this is just sugar, you know? It's just sugar. This should automatically launch the debugger in a new window for you to interact with. Yeah. Or you see an error about context terminal. Check the second on specifying a terminal window. So, can we set it not to open? Can we do no terminal? Because I looked at this before, and I was like, okay, let's keep the default. It seems like complex options. Set any parameters options you want. Yeah, and this is how we specify arguments. Yeah. Okay. And yeah, but I want to change this to nothing. pwntools. Let's try ChatGPT. pwntools spawns a new terminal when I won a wrong thing here. I want it. I want everything in my existing terminal window. Keep everything in your system terminal. You can add the ASLR false and TTY false options and use process. So what does ASLR have to do with this? TTY false, I totally get. Attach. No. Okay, attach. Okay. Let's just try and do TTY false first and see what happens, right? I'm thinking of stopping the interactive because this is not the problem. Well, it is the problem. But it is also not the problem because I can't even do anything, right? Now I close it before I saw an output. Unexpected keyword argument TTY. So where did it assume to use TTY? It didn't use it in its example here. Why does it have this? Because it thinks that's my program. Yeah, I don't think this is a good idea. I think it doesn't know what it's talking about. Of course it doesn't, but you know what I mean. I had hope for a second. people like the new terminal thing. I don't get why they did that, but I guess we don't agree. So, it's a forking server. That's why they're using SOCAP to say fork here. I guess. So I'll have to test this remote too. It'll be funny, but not now because we have a local file. So we're exploring what we actually have use for. We could do it like this, but we're not, right? We want to take the opportunity to learn as much as possible. Foreign architectures. Tips and limitations. Okay, it was very limited GDB stuff. Troubleshooting. Yeah. So this is where we ended up before with it. No. I feel I'm like this. Are my bright lights too bright? So all of the stuff I had to eat is gone. So debugging. Yeah, you know, we already saw that, but let's see if we have any luck looking at this log level debug. pwntools attempts to launch a new window. This is where we were, right? We were reading. Yeah, so nothing new, unfortunately. So I want it not to hurt terminal. Let's just sorry about that. Let's do context terminal equals and then like false something odd, because this didn't work. That was ChatGPT not being logical at all because it wasn't in its example. So context terminal split VX. access it. What will this do? Could not find a terminal binary to use. That's what I wanted, right? Haha. I'd rather not have it run at all than I have a horrible terminal. Could not find a terminal binary to use. Set context terminal to your terminal. So what if we use if we do this and nothing else, what will it do? Didn't do anything. So it didn't work. It didn't crash. So we don't see the debugger, right? So what if we do this? Oh. I think this might be the default. We'll see if it looks the same. No. So what I want to not run is run a new terminal. But there must be an option not to do that. So this is what we're setting. So what if we use it? So I see stuff here, right? This one says use tmux split v, right? This is its examples, and it doesn't work either. So what if we comment out this line just to make sure it works now? It does. Just closes the window. It's not still here. It's not open. I can't, It's the same as in DOS when you run a DOS program. It disappears before you can see anything. It's a horrible thing. We can stop it from closing by interactive though. But why doesn't its suggested thing work? So this is another suggestion it had. I saw it underlined there. Oh, that worked. So let's Google this thing that worked and see if we have either options for it. Oh no, that's not the one. How did that happen? This is the one I covered the last. Terminal and terminal. Oh, let's use an actual terminal. Right, very, very likely. So why did these words pop up in this? Because it's not here, of course, right? This is where we're in. And so that's what's in the config file. That's why we have it. The same functionality when we run this. X terminal emulator. That's not useful. I want to know what -e means. What does this option mean? I can't just test stuff, right? Or can I? Is this a command line thing? It is. And that explains that. And the command that we run is E. What is drop down mode? So I'm just telling it to run a program and the program's option. But I don't want it to actually start a terminal. I don't think this is the right spot to change that functionality if it's possible. So I'm just gonna ignore this for now. I don't think this is an option. I think there might be a way not to run the program, this function here. We didn't try that though. Let's give it a chance. Let's give it a chance. Or all these lines. Will this not open it in another window? If it works, I guess we're happy, right? So instead of using edebug, we're using process. Right. elf your binaries. So it is. This is what it had as code, the full thing. This. I'm thinking it should be e dot. P R O. Yeah, it's there. So this was our input data here. And then our script when it's attaching. So let's see if this works. Everything says GDB dot, so I'm assuming it's a functioning. Oopsie. So we have an attach. Process is a zombie already terminated. So we show that it doesn't work, right? Waiting for debugger. Debugger did not attach because it's already closed. So that's not an option because we have a tiny program that just has input from the command line, runs a function that's mega tiny and exits. So we could never attach to it in time, even if we forced it. But let's do that, right? So let's do IO interactive after this, right? Though it said already at the start that it didn't do it, but just confirming. It already says here it's a zombie, so I don't know. Yeah, it couldn't be interactive because it was already dead. So let's put this one back. And let's put this one back. So now we should have a GDB running. It's only in a different window, which we didn't have it to have if we just run normal GDB. But at least we're connected to it. So my GDB, if this was R2, I might remember some commands, but I haven't used GDB for a long time. So I'm picking my notes up here. GDB. We can step through things. N for one step, and we can and break functioning. That's what I used there. Let's see if we continue right. So let's see if we can do a next, right? So if we do an N, can it find bounds of current function? Next, writing it out for it now. Can we do C? No such file or directory. Validate C. Okay. Yeah. So it actually pauses when it's launching. So we do C again. We're at our breakpoint, I think. It just can't find the validate C because it doesn't exist. Continuing. Exited normally. So it's already exited. So let's queue it. So will this one stop in a bit by itself? Let's read on while we gave it a test. We tested it, though it looked very suspicious. I want to brush my teeth. That was so sweet. Just sugar. Here we go. It's red. Details. Yeah, right. We could go to start too, but I really wanna just be able to see the output of the program right now. That's what I want. I don't think we managed to send it the right things. Arguments. So what if we were to do GDB debug instead as a test? Maybe not this complex thing. Unfortunately, when using GDB debug, the process is launched under GDB server, which adds its own environment variables. This may introduce... Yes, we don't want to do that. Complications. This only occurs when you launch the progress under a debugger with GDB debug. If you're able to start your process and then attach, you can avoid. We can't. But so it's creating them even this way of starting debug, probably then. So let's try this. We're using GDB debug, really, we're just doing it differently, right? So rec vols. So let's see what that says. I read as quickly as I can here. So we're in interactive. Receiving all data. I'm so tired. I think we'll hop out. That was me tabbing. We didn't get any of that information either. The print. So let's just print testing. Testing is there. It's there. Yeah, I'm really tired. I'm really tired. I don't feel like I should be tired. I've been doing this for 5.5 hours though, and it's 22. I shouldn't be tired from this. This is relaxation. Let's just sit up for a bit. I was actually, before I started eating stuff, before I was yawning a lot when I started streaming. And then I think of it and I feel like yawning again. Oh my. Oh. Environment variable orange. Ordered. Alright. Yeah. So we're talking environment variables and using them for some exploit here. And here we have args. Yeah, so this is what we're gonna use soon. Send stuff in there. Some children require that we are launched with argv0 set. We're not actually going to use it. Specifically, even that it's null. Since version 4.13.0, pwntools supports launching binaries in RGB while modifying or omitting argv0. Args can be set to anything as long as it's with a binary to launch the exe parameter. exe. So we can do args also. Let's do that instead of what we're doing. So there. So now this is explicit that this is an argument. So if I don't do interactive, I won't be able to continue it, right? Get multiple values for argument args. Yeah, so it's different. I get it. Okay, so this is from the other file. Let's skip this bit. Right, we don't need this. Yeah, I think I want that still there. And this is more belonging to this. And now we're gonna add file name. No, it's not actually file name really anymore, right? So if we just over here, loading. Yeah, I'm
VR
leaving.
Mechatronics says, "Hey, how is going?"
Hi VR. Yeah, so it's kind of slow now because when I mouse over this, it's supposed to pop up the arguments. Let's run it instead, see if it works. So it's good. It's good. I'm just trying to learn something. Still multiple args. Let's undo then. So let's move the context terminal up here anyway to the log level. And let's put a little space here. So how are you, VR? Everything good today? It's Friday, right? Always nice with weekend. Alright, we can skip this breakpoint that I've been adding. As I'm doing it here, we're having 2 breakpoints in the same place. So I was like, why do I continue twice? Okay. Let's see how it acts now. Still args. Yeah. Oopsie. So I added the args here as it said that I could do this to be explicit. So let's remove it again. Now we run it. And see. I think it kind of looks like the same. Since I already set the breakpoint and I set it in the same place again, it's probably the same, right? So, yeah.
I'm very happy, because versus code get Gemini and my phone will get next 2 weeks voice chat for real time. So now I can speak live loud in English in non-English speaking country.
Oh, nice. You can always speak English, you know, I'm doing it. You can pretend you don't understand Danish and speak English to everybody. Just go to anywhere, right? And just talk to people. Are there not like English courses, basic English courses, or advanced English courses? Probably, I guess. As you can speak it already. Could. If you just want to practice talking, you know. Or you can just read a book out loud. If you just want to talk and hear how you sound. So we have a very extremely simple binary here. So maybe that's a bit of a problem. I can't attach to it because it stops in 2 microseconds a second.
Now if you offer me 20 million krona, I will not, because waiting 20 years for admission on study, and when I get it, it'd be time for pension.
No, I mean like normal, simple courses. You can just meet some other people. Just go to a shopping center and talk to the people working there. Or other people, you know, whatever. Talk to anyone. And I'm sure there's like free courses, aren't there? No? Yeah, I know you have problems with the education system there. Yeah. So args can also be this. Right? Which is good to know. But args, we couldn't use args. This is where I got it from. It didn't work. So, as long as you have exe. Right. So what if I were to do that again? It's not a big edit, and we can copy the line so we don't have to redo again. Let's just comment that one. And let's do gdb dot debug. And then we do exe equals file name. Comma args equals and comma gdb stripped break validate IO interactive, and we save and run. We get an error. Could not find executable. No. So what if we do full path to executable instead? Oh yeah, I did undo. So this is correct. It was correct. So there. Cool. Cool. This is new. In start. Did we have that before? At least it's much more lines. No debugging symbols found. Determine the exe file. Reading symbols from validate. Selected architecture i386 not compatible with reported target architecture. Architecture rejected target supplied description. Build ID mismatch between current exec file. Home Kali buff validate. Ah. So it's the same file. Make breakpoint pending on future shared library load. Nah, we want a queue. So that's interesting. So it's because I already loaded a file. Here. So I loaded a file and then I loaded another one, which happens to be the same file, but they apparently had some kind of conflict because they're loaded in. One is loaded in GDB and one is loaded in pwntools, I guess. No, it's not that. There's something else. Detected exec file. Exit mismatch. Handling currently asked. Load new table from. Answered yes. No. Input not from terminal. Yeah, I don't want anything from Python. Well. I guess we queue this. And we realize that the GDB dot doesn't really work, right? So what if we use a full file name? Let's do full file name. So home. Kelly.
When I was at the employment office, they offered me a psychiatrist's appointment. Then I asked ironically if I could speak English there. XDI went and they said that if I'm not Danish, I can't use a psychiatrist by law. Then I went to the job center and told them that, and I remind them of that every time. And now I have the 13th consultant because the 12th one has already quit when I come. XD.
But I don't think that's fun. You know what I said before. You're welcome to answer my messages. So you know Danish, right? Because otherwise you would practice English all the time, right? You must know Danish, right? Then I went to the job center and told them that. Yeah.
Officially I don't want to.
Why? If you live in Denmark, you should speak the language. Why not? So I know you've had a lot of problems, but I'm thinking that the only way to get people on your side to help you is to, like, say yes to the help they offer and, follow along with their suggestions a bit. And I know you probably did that long ago, but maybe there's new people now. Maybe you need to show that you're, like, friendly and stuff, you know? That you wanna get help from them. If they have to be the ones that help you, that you're dependent on them, then you really have to try and be very friendly and not make them not want to meet you again. You know? It's a tough situation, I understand, but it's, you have to do something to change it. They're not gonna change that, right? So you have to be the adult one and change it, right? So I think we're done with that one. Debugging is the one we did. Logging we already looked at. There's only the rough one here left. So I'm kind of thinking that there's so much stuff missing. But this is not the docs, this is just some examples. pwntools tutorial, right? This is a basic tutorial for this. It's not all the information that there is. Yeah, so we don't need to bypass this now. But let's just skim slightly. We just remember that there's something called ROP, and when we need it, we're gonna look at it more, right? For now, that's good enough. Look, context binary elf. So they actually used what we did, but we did this E and then we did this equals E, which I think is prettier than having this in this case. Calling functions by name. Oh.
I don't live here, I just came here to study. People who live here got the right to buy a house, a car, a family. I didn't get it. 12 years ago I got the option to go to the US, but I gave up because I wanted to do a master first, and that was the biggest mistake of my life, staying here. Because now I don't have a master and I can't get a visa again. It's a trap.
Okay. But you live there. You're not born there, but you live there, right? So you say you don't live there, but I think it was a mistake because you live in Denmark, right? I'll just scan a bit more of the text here. Half that lives here. There are so many things here that we haven't seen.
Waiting, just waiting, like on bus station.
Yeah, but you're still studying yourself. You're learning a lot of things, right? You have so much knowledge. You learn a lot of things about mechatronics, AI, a lot of things, right? What happened with that job you were talking about, Singapore? Tell me. So interesting.
It doesn't matter, I won't get a visa for to private study.
Yeah, so if I was Denmark and I knew that you came from another country to Denmark, and the only reason you want to study is to move to another country, then it wouldn't be economical for Denmark to give you education and then say bye-bye, right? So maybe you have to make it look like you want to work there. If you tell everybody that you just want to go to the US and that's the only thing you care about, then maybe it won't work, you know. Maybe you have to have like a in-between goal at least of working in Denmark. Maybe they'll be more like friendly and help you then. I don't know what you told them, you know. There's interesting stuff here, so I'm gonna actually scroll through it again. So ROP is ROP elf. And that's a ROP object. So we're not really actually going to use this for this anyway, right? because we're running this on a machine that don't have pwntools. So we're gonna have to get the actual I guess the string we have is good enough, right? So, oh, sorry. Oh, you didn't even see what I was doing. So we have the...
Yes, that's right. That's why they accept other students for exchange, and they told me to work 5 years before, and work off 2 years of military service before, and then after that they said me, is no place.
Okay, so you worked for 5 years and 2 years military service? Oh. So, yeah, this is the one that's good enough. This is really what we need. This is all we need. So we could just copy this, and maybe we should finish the box. And we have read through all this. There's much more to read. But maybe we should finish Brain Pan. I have to think a bit on that first. It is also a bit late now. I'm thinking of... Yeah, I'll continue. I'm not gonna stop streaming or anything. So... where did we go? We're here. So we have our suite binaries here. And we don't have the document for the box open. So I'm gonna think just simply, and so I'm just pasting this here, and let's also put, make sure it was the right one. Yeah. Let's just grab the code. So to make it simple, I'm gonna make a simple Python code.
All because I was born before '89. They told me this twice when they rejected me at the university. 20 years younger student service girls told me this. I'm not only one who was rejected.
Okay. I have such a hard time understanding it, VR. All the things you say, it sounds very, very odd. So I'd love to call them for you, if I'm allowed. I'd love to call them and ask. Okay? So I'm thinking there might be some misunderstanding or something, and you get very emotional, and it's like you can't communicate good with each other, and I'd love to help if I can. You know, I'm serious. I'd love to help you if I can. So it would be great. Well, okay, it's long enough anyway, so we can have this too. So, let's keep the output. Let's just R2 it, right? We could even, yeah. So I'd like to get a nice, like, easily repeatable way of doing this. And let's type some stuff. So as this is a command line executable that just takes the input parameter argument, I think is better. Input argument and the execution is finished in no time at all. There's no way to attach to it. It's also not suitable to use a graphical debugger. Graphical debugger. Let's go for R2. And I've been doing all these Python things, and then I go R2 anyway. But I'm trying to learn, right? I learned a lot. We're going to expand the notes for this. So, simple checking it out. We can even use generate a string. I'm thinking, how much can I Python this? We can run it from Python, we know, but yeah, we can just run it from Python after generating the shellcode. So let's make a new one called validate fusser. It's not really fussing. Well, I guess. I'm gonna have to run it in a debugger. Yeah, we're gonna have to run it in a debugger. I'm regretting that. So let's just make a simple cyclic thing. Make cyclic string, but let's use the pawn of the command line. So could we do cyclic here? No. Let's use the script. So we have cyclic, Elsley, and we have OS there. Let's remove it. So we do this bash copy thing. Generate cyclic. Well, it's pawn cyclic. I guess it should be pawn cyclic generate, right? That was not efficient. I don't think it's finished even. Yeah, it's not printing it. So oops. We could also make something that runs a argument and stuff, but this was just to test the function, right? So here we have a long string. We use so this is really the only reason I wanted to do command line, because we could have done it. We use pwntools, cyclic, to generate a non-repetitive string, and this is a string. So then we're gonna run R2 with this, and I don't remember all my history. So history, well, grep R2. I'm curious if I grep for history in my history. Oh yeah, so we just put the data in afterwards. So we do R2 DA validate, that I already did there. Then we do the argument, which is this. I'm just copying the string to make sure I have the right thing, and we're sending it in. And let's just continue. No, that's not what we do in this. No, we were in GDB in my head. So not GDB, but R2, and I'm obviously struggling to remember all the commands. So I remember AFL and PDF kinda good, but this was just gone. DC. Right, it calls everything D something. Well, not everything, but lots of things. Signal 11, and here we have the simple output. This is what we want. This is the crash information. So we run R2. And the only reason we run R2 is because if we do this outside of R2, we wouldn't get the numbers that we got now. I'll show you here. This address here. It is part of our cyclic pattern here. And let's remove my misspelling because it's just complicating stuff. I usually skip all of these two. Let's keep a few lines. That we could use, and there's more between, and then we have that. So EIP ends up at this, right? Ends up. I'm thinking, is my keyboard dying? I don't think so. It's like me. I did kill my old keyboard with some liquid. I don't remember what it was. I think it was Nippon Soppa. Well, I don't know if it's dead. It's still drying, but it's been over a week, so I should probably try it. I think it's probably gooey. I mean, I had lots of water on it. So this is a command line executable that just takes the input argument. We use pwntools cyclic to generate the non-recursive string. We are on R2. EIP ends up being, and then we're gonna take this number here, and we're gonna put it into the other script we have. Let's open a new tab in case we want to run anything more there. So we have the opposite, cyclic find, and we're gonna put this here. Should we fix these so they have arguments? So it was long since I did that, but maybe it's nice. Nah, not now. No, I just wanna do this /pwn cyclic find pi 116. So we knew it crashed at 120, but not 110. So we use cyclic find. Let's add these here too. Cyclic find user. Yeah, my fingers are used to typing user. we used pwn cyclic find to get the position of this in the string. There. This is the position where we will. Yeah, I'm gonna prepare a script for this. I'm just sad that I couldn't send stuff through GDB in Python to get this information for me within the script, and just send the string, get the position, send a new string, automatically do it. Totally automatically. I'm thinking it should be possible, but I don't know enough about pwntools yet. I need more. And this is like manual steps. But let's slightly automate it, right? Yeah, we can make a directory, we can make files, we can output stuff. We can even read. Right. So now we've already done this far, but I still wanna automate it if I can. So let's go back here. Let's just grab this line, right? And let's make this validate thingy. Validate exploit creation.py. So I'm looking for validate in it. So the first step we did is to generate a string, right? And also we did this. And the actual last line of the output here is the thing we want. So this line here contains the number we want, right? So first we want to just generally run it. Oopsie, I'm typing in the wrong place. And the wrong screen even. So first R2 command line equals, and I'm gonna cut this. Executable equals, and dot slash never hurts. We're gonna run it itself too. So steps. First we do generate. Why not def this? Def generate cyclic. Oh, I did minus. Generate cyclic. Let's just do the cyclic one in here. So let's close the ones we got data from, and for now let's just this is because this code is not mine. I would have done this once. So let's just do like pseudocode here first. Run executable executable. First, run executable with increasing the size arguments, and then we do after crash generate non-repeating string crash length equals 0. Crash length. Well, it's actually will be 120. Let's just put anything here, right? After crash generate non-repeating string, run executable in R2 with string argument. So this will actually have a name here. No. And the other one probably too. Oh, cyclic string. EIP position. Find EIP position using R2 output of crash address. And for now, so building the logic slowly. So what I need to know is how to run a normal command. I guess I've done that several times, but I want to capture the output, and I think Pwn can do this, right? We've seen it. So we're actually going to get to use Pwn for this. And it is the most basic tubes here. And I think this is the best actually way to start it too, right? So it's example here. It's actually starting a program. It's sending a line. We will need to start the process with an argument instead. Here, yeah. So this is ours. This is what we'll do. So I'm like, my brain is bouncing between command line now. So I grab it. Oh no, nay, right, we're in Python now. So this receive line will not be one line. So I will get to how to find all lines. Right. Yeah. And the output will actually look like we have it here. Wrong machine. So this is what the output looks like. DC. I had to run DC. So what is the R2 argument? R2H to run it immediately. So I don't need to do AA, I just need to do D, right? So 1000 bits. Here's the debug. Enable debug mode. Maybe I shouldn't even do debug. I don't know. Now let's test different things before we do it. Quiet mode. Quit after running all C and I. No, we don't want quiet. Quiet mode by prompt. Quit faster. Use project list if no arch. Initial C. Start R2 is sandbox. Open filing right mode. Open without except fly. Same as E. Do not load strings. So, this is what we run, right? Oh gosh. Well, let's actually let's skip the A and let's do C. DC. My god. And there we got the error, right? So if we quit and we do this again and we just do DC and we have the data, right? So this is what we want to replicate and we get the data. And let's put the full output here, right? So we run this, we see this information on the command line, and when we get the 0x, the first 0x, we will send DC. We'll actually just do it at once. So I'm gonna add this back. We're gonna remove the end. And we're gonna remove this. And the C. This is going to be executable. And this is going to be the cyclic string. And I'm going off because this is the wrong step to do this. So Control C, undo, 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 and no redo, and counter test string, and no, we want return code here. And over here. Here. This is where we want this. And we're gonna extract this from this. So, oopsie. Run executable with increasing size arguments, meaning this is a loop. For, oh gosh, no. While, so, Python, while, does that exist? Yeah, of course it does, because it says while true, and then we got it, right? So, while true. I'm like, yeah, it's uppercase. My languages are a mess sometimes. Yeah, let's just do two steps. So, depending on the return code, if the return code is equals crash. This is not actual code, if you can't see. If return code equals crash, save. Save length. Break. I think it's just break. We can test it. Break. But it's bad syntax there, so. Well, through I operator as a test string, and we need a value saying the increasing string size. So, length, first step equals 10, length equals 0. First step plus equals first step. Oh, and let's just do A times length. So IO send line. Oh, that's for R2. IO receive line. It's also for R2. IO dot. Nothing. Nothing. So let's see what the process has. I shouldn't search before I think. I think I will lose time on that. So this is the tubes, right? Receive in. IO unpack. IO process. IO interactive. Remote. Yeah, remote is cool, but that's not what we want. So I want to have the return code of exited program. That's what I want. So maybe I don't even use pwn for this. Only for the other thing. So Python run command and get output and get exit code. How do I exit state is set in a shell script in Python. Runs an external command in Python and returns exit code. Sub process p open. Return. Proc. Subprocess p open. Proc communicate. So Python docs. So let's just do subprocess run. So instead of process, we do subprocess. And we have the right way here already, because it uses the same. And my brain, it is not really there anymore, is it? So let's do some C comments in Python. That's nice. So we're gonna comment these, but I'm indenting them on stuff so that I see that these were the ones that were not. So this won't do anything. And this won't do anything. It will just work, it won't output anything. So we have executable, we have R2 command line, which is actually here. There might be 2 spaces here. I don't think it cares. Echo DC. And then we have to fix the getting. Sorry for being all over the place here. So it is not the 25th yet. It's just 1 hour left though. So 6:30. User bin and Python. I'm just gonna check something. So I'm talking to my mom. So I tried calling her before. Maybe she was out with the dog or something. Let's see. I'm just seeing I have a last read Discord message. Then I have to like check. Blue sky. Oh, so I need to go there and look later. So, right. Let's see if we. To start with, we're gonna skip this. That we're gonna change this to 50, and this is not useful anymore because it's, well, length 50 and length, oh gosh, this should be length. So if I do crazy stuff, correct me please. And this needs to be ups there. So I have no idea how sub-process will happen at all. This is the first test. I might run it long go. So I don't think this is even plussed. So chmod, all poor things in this directory become executable all the time. So /val date exploit creation. Yeah, I kinda thought so. Yeah. So I don't know if it's import sub-process we need. We do need from pwn import star, because we're gonna use that. And where is sub-process? Module does replace older system spawn. Sub-process module. Yeah, so it's a module. Import import sub process. I typed there at the end, so I don't know. Feels like it's more correct. Module object is not callable. Yeah, because we should probably like do a from and stuff. Let's try that. So I don't wanna Google too much here. Yeah, it's not callable. So undo and let's actually read. Don't you have a code example? OS? When it says sub-process module, I'm thinking we import it. Especially as it says it's replacing these. So I don't know what I've been using before to start with, but as we got this as a suggestion, you know. So Python sub-process example. Load page, load. Sub-process run. Oh, I forgot the run. That's probably the problem. I forgot the run. It's because we had process before, right? So I did sub. It's running the program, and we can see the output. Not as horrible as the other stuff. Very nice. Now we just need to get the return value of the process, and I'm kind of thinking we don't need to Google at all. What is I/O? Look. I don't know why it's read for such a long time. So, and now we do 200. And then we run it again. -11. So, mega crash. So, instead here we do if. I even wrote return code there. It used the same words that I did. If return code. If not, return code equals 0, because that was the okay value. Print we could just do length later. We don't need a new variable because it's not. Well, this is more clear, right? A new variable for clarity. That's okay. Program. Crashed at plus str length. So so let's just check through the logic here. So we have length 0, we repeat forever. Length increases from 0 to 10. This is run with 10/8 as an argument. If it didn't crash, if it didn't go okay, it crashed. We write out the length. We save it in the new variable, which we don't really need, but it's prettier. We break the loop. And we're gonna do a print. Well, let's print the cyclic string, because that's the next step, right? So I was gonna print we're out of there, right? Well, we can do both. Print. This is like comments too. Generating cyclics string. Non-repetitive. Well, cyclic is not as clear, so that's why I wasn't clear when I only got ace, that it was a problem really. But it was me calling a function called string. And it got messed up. Use the same name as other stuff. You shouldn't have a Python file called string. Don't ever do that. You'll get pod problems. Generate non-repeating string. And then we don't need the comment anymore because we have a print saying that. Then we print the string. We don't even need anything else in the string here. But we're gonna plus. This will be a byte, so it won't be able to do this. We'll have to do this. And then do. What was I gonna say? I don't know why I needed that. Cyclic string, generating non-repeating string, and then the string. We can do this, so string it. That's okay, it doesn't need to though. So, not a lot of unnecessary characters. When we see the cyclic string and generating non-repeating string, well, let's also make this a print statement, and let's running executable with increasing size arguments. Program crashed at. So we could like let's oopsie. Let's print comma and equals dots. So we're getting a few dots there. And then we need a backslash n here, or it will look very funny. There. I think that's good. Alright, it's also putting the output there, of course. Program crashed at 120, generating non-repeating string. So far, so good, right? All works. So next step is to see if we, because we can't use this, we need to use R2 now to run it. And we're not stopping R2. We need to read the data and we need to send data. So it's not as simple as just starting a program and right? So run executable in R2. And this is also a print, right? So running executable in R2 with string argument with the generated string. There. And now we're going to do cyclic string. I don't know why I didn't like that. I don't think there was an underscore. And then we're going to send DC. Then we need to know, how do we find all these lines? Or do we have to loop, right? So we're gonna check IO receive stuff in pwntools. Resive size, resive all. But I kinda want the lines. Lines, can I get lines? But there's a resive all, that's nice to know. Let's open that one, by the way. And then we have resive line. Resive line contains. So it contains B. Talking to world. Resive line ends with, contains. Well, it also starts with then. Resive line pred regex starts with. This is what we want then. Start with B. I'm thinking like B and S will also be in here, right? Resive line starts with, and then we'll start with S here, right? So returns a string, a delims, keeps. Now let's go the most basic first here, right? So let's just start. That's contains. Yeah, so I really want starts with, so contains we can close. Time to switch ear thingy. So, let's see. Starts with, let's just check on here. We have lots of stuff. Press it until. So it's called choose for some reason. First of all, receives data until is reached and closes the tube. Yeah. So we will definitely want the str one. Byte array. Maybe string isn't the best. Keep receiving lines until one is found that starts with one of the limbs. Returns the last line received. I might just do the lines, receive line, and I'm assuming there's S version. But let's just do this. Let's do a new search. What did this one? Oh, it was the sub process. Python res line. Yeah, pwn while isn't this what we just were at? Yeah, this is just all the functions. Oh, there's also examples. Yeah. So process. Where's a line? Read line. So rest of the line. There's also read line. Receive a single line from the tube. Line is a sequence. Yes, I wanted an example with a while, and I didn't get that. So there's say goodnight to my kids. Back to the fun. Who'd wanna watch Netflix when you can do this? So let's start with just testing the receive line function, right? And let's move this up here so we don't copy it a million times. So if we look at the output, we had 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this might be different, right? Actually, this is supposed to be sent when we receive the first this, right? So this, and then the second one of that is when we got it all. So imagine we have the same situation, right? So let's say we send this already at the start, right? But we can make it more intelligent than that. But I'm assuming it will be queued, right? So let's run this and see what happens. And we're gonna have to actually get the crash address here. So we get an error. Oh, /r2 does not exist. Where did / come from? So R2 needs a full path. So let's do usr bin R2. So there. Running executable in R2 with generated string does not exist. Oh, I get it. So probably we don't need this. But this needs to be arguments. R2 arguments. So we don't need the DA either. I don't know why I had A. Copied. Oh, it was old. R2 command line, R2 arguments. That means R2. What did I copy this? So what if I do this instead? No. We're in Linux and I tried the Windows button. Usr bin. And let's R2 path. R2 arguments. I don't know which I prefer really. R2 command. just R2, but I don't want to short because I might overlap with something that exists, you know. Whatever, I don't care. No, this is just for testing. R2 command line executable. R2 command line is not defined.
Zeros Faraday says, how are you liking pwntools?
Yeah, I haven't gotten to the cool stuff yet, but I'm liking it. But we're actually using sub process run here to just run this first here. So what do you think of pwntools? It looks very cool. But yeah, I need some things are annoying. So where were I? Right, I forgot to change the variable name. So this is supposed to be
It's pretty awesome
path.
for what I've used it for in the past.
Yeah. There's a path. And then we need R2 arguments. And executable is the one we're checking. And the cyclic string. That's arguments. And then we're gonna check here if we need to loop this. Or if we just do receive until these characters or something. Because we're getting this twice. So this is for this, but I'm exploring and testing. So what have you used it for? Freddy, tell me. And welcome in, by the way. Welcome in. So you've been in Gar's events, right? Or I think maybe. So. So I noticed something that I need to fix. All of these. Let's backslash n them, right? Because this was not readable.
Simple buffer overflow CTF circ, and Jaeger is awesome.
Yeah. So let's print these. Not just get them. Yeah, did you see his Hack the Box stream? Let's abort that one. And let's run it again. Now we can see a bit the steps here. So we're generating a string after what we found there. We can really
part of it,
these.
yay! Really cool stuff.
Yeah. So, running executable in R2 with a generated string. Starting local process. Text it not byte, assuming asking no guarantees. Text is not bytes, assuming ASCII. Text is not bytes. Height 30. Sendline DC. Is this a line then? That's got the problems. So we just B this. Let's abort and run again. So, known. Oh, I'm printing the send line. We don't need to print the send line. It's so slow in removing the red stuff, so I believe I did something wrong. Okay, now we're getting B's on all these. Relux not applied, please use Relux bin cache true next time. Yeah, so there's string versions of this, right? Oops. That's supposed to be Control S, not Control A. So let's see now. Now we're getting somewhere. Oopsie. Running, execute, starting local process. Yeah. So this is from this is from pwntools. War Rolex has not been applied. Please use E. Next time. Info. So let's compare this to our test output here. This is what we got. Warn, Rolex not been applied, meaning this is also from there. Info. Then we got this and we sent DC. So you can see DC here. And there's also some other stuff. So what do you think about putting a \n after DC? I never did that before. So we're still getting some funny characters. But now we got our buffer overflow. So either we find a line that contains signal 11 and get whatever is after address, or we get this one. And this might be more, we might grab this one instead, right? So maybe we do this one. And the script ended correctly. And this stopped the process though. I don't know why. Maybe because I was reading too much. So I don't want to have lines like this, of course. There should be a reason why we read the lines and the reason why we stop reading. And we should send this when we get the first one, probably, right? So I checked for functions. There's receive untils until so maybe we should check this thing out instead. And I already have receive read line. Oh gosh, there's so many reads and receives here. Receive line contains ends with, so starts
Got it,
with
but have a great
S.
rest of the stream.
Yeah, okay. Thank you very much for coming in, and you're welcome back. And have a great weekend. It's Friday night. It's almost midnight here in Sweden. So, receive line starts with same as starts with, but with string. Just a string. Yeah, Friday. Decode the result using. Oh, it says 4 hours? It's 7 hours 15. This, I should change my stream duration thingy. It's bad, apparently. Decode the result using context encoding. Note that the binary versions are way faster. Yeah, but I don't need fast. Keep receiving lines until one is found that starts with one of the limbs. So give me an example here. Drop equals true, timeout default. So let's just grab more lines here. More lines. Actually, we can do this. Sorry, I clicked shift control. Sometimes it happens. So instead of this, let's comment one of the lines. Let's edit this one. This line starts with, and then grab the S one. But I'm assuming it's the same, it's only the return value that's different. So bytes, and we want what I put here.
Mr. K98 says, face blue smiling.
Hi, welcome in. How are you this Friday night? Here. So, IO, receive line, start with S, and 0x. And the first time that happened... Oh, I'm getting a full There, just got a call, sorry. At the midnight hour. So let's see now. You're heartbroken. So why is the TTS not reading? I don't know. Okay. I don't know why. So hello there. So I can send some hearts too here. Yeah, so I'm back. Let's continue with this. So I was testing to see if we can be more intelligent when we send our data. So our send is over here. So this is the starting the process, and then we use this. But let's delete that. So we're actually going to do this twice. I didn't mean to cut it. Well. Will I remember this? Let's keep it there for now. So this one is here. So when we receive the first prompt, so this is a prompt, then this is what's happened. And the next time we receive the prompt, we actually gonna send a quit.
Rootbin
Then we're
says
gonna do
awake
something
late.
in between there. Awake late? Yeah, I don't know. It's just, it's not even midnight yet. It's 2 minutes left. So we're gonna send a quit here. But in between here, we're gonna do something else. We're gonna do a contains. And that data we're going to save. So we know that this line here, this is what happens when there's a buffer overflow. We'll get a signal 11. So we're going to try and find a message with this string in it now. And then we're going to read this data after address, because then we can't happen to mix it with these. So let's see here. If we go back to here we have them starts with, ends with, contains. So the contains, and we want the contains as one, and the contains as is as it contains, but with it returning a string. So we're going to go with this one, and I'm gonna put it, just pasting it straight there, and we're gonna get an example. Contains. Okay, so just what characters? And here's, oh yeah, so they can even be two things. It contains car and train, and I'm assuming or here. And there could be more complicated sims too. So let's see here. Yeah. So the same syntax as we have for the others, meaning we have parentheses, and we have a B, and then I usually use these. It doesn't seem to matter in this case. Well, all examples use these, so well, why not do it? It's just my brain that thinks this is for one character, not for a string. So let's go for signal 11. So if we get a signal 11, then we go into we're going to do something with that. So let's start with printing it, right? So I want to put in a variable and then we're going to print it. What are we going to call it though? And we can say buffer overflow colon, and then we do, of course we need this around there, plus, and what's a string? I guess we say, let's do buff string, short for buffer overflow. And then we run this and we see what happens. And we're not using any data yet because we haven't got anything. But this will be, next step is to find this string within here. So the next thing is to set that here actually instead of over here like a static value. So let's run it and hope I saved it. And it seems to be waiting forever, which is not a good thing, right? So there will be stuff happening that we're not seeing anything. So it totally didn't work. And I crashed it now, but with this. I aborted. Ooh. Let's start with removing the bees and see if it will work. And if it doesn't work, I will try contains. Oh. Return packaging decode func self. Yeah. So let's do a contains. And see if this works better. We getting no output again. So there's only one thing to do. I want examples now, right? This is what we want. And we do have an example here. T reservoir lambda n something. We didn't put the timeout to. Maybe we should, just to make it not crash. Let's do that. So read the docs. Exploit scripts using pwntools. Pwntools cheat sheet. Documentation. So we're gonna search for this, and it's not in here. Not even this is in here. I'm gonna click this anyway. Okay. Okay. Well, let's see if it's in here. Phrase not found. So why did these pop up? We have a starts with there though. Your password is. Yeah, so they're using B. They're not using any data that will be received with this. Rest of all. Con send line. They're using con for their connection. Receive until new line is receive line, of course. Receive until given keyword. Yeah. More and more I'm thinking I will loop through this. The lines and just get every line and handle it manually instead of doing this, because we can just use normal search through the strings, you know. So let's make a loop instead and use the receive line. I can just save this for a reason. So we still need the send, and we still need this information. So this will instead be some kind of if here. With the string, right? And exactly what it will be, we don't know yet. This will also be an if with a string. And then we'll have the same again to later place there. So let's make another loop and start it. We didn't make a comment. Yeah, we did here. There's a comment there. So while true, and find that we could print it, but we're definitely gonna save it. And I think it's a good thing to print it. At least for now, but maybe we don't always want to print it, so let's put it in a variable primarily. So I should change my tabs to 2 steps. No. I haven't been doing this that long. Then I wouldn't be learning this. So, well, true. I've worked in IT for a long time though, in programming. But I'm like 1.5 years. It's almost 2 years though, I guess. With cybersecurity stuff and hacking. So, line equals IO receive lines. So, print line, and then we can just do simple ifs. Right, so we have if in line, and I'm gonna switch this back so it looks like my other code, or switch it to this. If this in line, we're gonna make it very basic now, so we're gonna do print found, and I don't have it, so I have to type it. 0x, right? And then we're gonna do we're not gonna do this within the loop. For now, we're actually going to send it for. That's not how it's going to be. Then if in line. Let's do. Rather, we can do this. So. Yeah, and after this loop that will go forever, stuff will be done too. It doesn't matter, you know. It will be going on forever. There's no exit. Well, actually, we can do that here. Right, let's do that here. So, let's just break. And then this will be done. That's good. So the only thing we need is to pick out the data we want from this line a little later. And we need, of course, to do the send on the first one of these. That's what we want to do too. Started equals false. Why not, you know? Why not build the whole thing before you test it? So if started equals if not started equals true. There. So should I do this too? Nah. Let's run it now. So it doesn't work. It doesn't work. So first thing to do is to print the whole lines. We're printing the lines already. So why is the line not printed? Then I'm getting used to writing bad things. Might line actually be something, you know? Received line and line will be replaced with received line in this case, but yeah, in this case, and not in this case, in this case, and not in this case, because we're finished, right? So so received line is I receive. Then we print the received line. Then we check stuff for the received line. But if this works, we should get more output, at least one line. And if it breaks, let's put some output here too. Loop ended. Sending quit. Print. Sending DC. Starting. Sending DC. That's good enough for now. That's not going to be kept. So. Info, libc, fc, offset, and the warn, both these lines. Oh, right. So we want to strip this line. Dot strip. Is that it? We'll see. Yeah, so now we're getting no extra lines. We're getting the two first ones, and then we're not getting anything. Which is odd. I'm kind of assuming if we comment these out. So if we do all of these comments, Shift Control 7, yay. If I Shift Control 7 again, oh nice, toggle. So save, Control C, I run it again, and we're not getting anything more. It's not the ifs that are problematic. Why doesn't it work then? So it will only loop received and print. So next debug step. Let's comment the whole thing here too. And Shift Control 7. And then we go 1, 2, 3, 4, right? This is exactly the same as a loop. If there's 4 lines, 4 turns of the loop. And let's abort and run it again, and we're getting the same result. So why isn't it running further? Let's go up. So libc fc offset. This is where we've stopped quite a few times now as I've been testing it. This is before I did the strip. Same result. Here is what? I didn't get any outputs. We had some other problems. Here we got the full thing. And this. So here we got all of it. Oh, right. So we send the DC here to get the next line. So we get this line, and DC is never sent because the if is not done. And then we don't get anything more. So if we instead comment this, and we uncomment the whole darn thing again, and this line We actually gonna put it up here. It doesn't matter if it's doubled. Okay, so you know, it doesn't matter if it's doubled, because it's just a command that starts a program, and if it's already ended, it doesn't do anything. And then we're doing Q after, so it shouldn't matter. So now we get an error. Buffer flow equals buff string, because buff string is not defined. Okay, because it's called received line. Buffer overflow. Okay, yeah, I borrowed that. I already had written it, and I didn't have anything there. That's why. We'll use that for something. Do something with it. So let's just run it again now. And suddenly we found this. So if we now remove this again, and was it that error that changed it? No. So it's not printing it. Why? This is not correct. But it doesn't really matter, because we can do this here, and we can like skip this totally because we don't need this at all. It just puts this in the buffer until when we have a prompt to print it on. And this is what we need. And the next that reacts to a prompt is after the loop. And after the loop, it will be there. So that works. Loop ended, sending, quit, stopping process. Buffer overflow, colon, that's our output. We're repeating what we already had here, just to in case we don't want to print it all, you know. But I don't like the starting process. Maybe we should change the output of that to not show anything. I don't want to have run executable in R2 with generated string is mine, but this line I didn't do. It is and also stop process, starting local process and stop process. Let's look at the logging in this. Logging. Error warn info debugging. Yes, I just want errors. So let's see if we can set error level debugging or error level logging. So we have logging at the very top, but it should be commented out. Error log level. So let's put it like here. And error. I don't know if this works. This is test, okay? I don't want any output, so I'm trying to turn it off. And it worked. Good. Knock on the door. Hi. So, my kids, I think it's Horror is getting it full. But he's getting a new one. That's actually been waiting for him for over a month now. Finished. But he's autistic. He doesn't want to see stuff. So, let's see. Right, so we're gonna first of all, these we'll say bye-bye. And put the command to start running the program in the buffer. That's what's happening, right? So, starting false is not used anymore. While true, receive line. Let's remove the odd coloring. So, receive line, we strip it from the new line. It also would have stripped spaces and stuff before and after, but nothing in the middle. And then we print it. If it contains signal 11, we print buffer overflow received line. Meaning we can comment this out, right? And the loop ending is just for debugging earlier. And this is what the outlook looks like. The output looks like this. So this was my example. Then we have this as the next step. Yeah, actually we don't need to paste it because it's already there, right? Though actually I need to paste it because it's not anywhere else. So it needs to be somewhere. We're just gonna update this to bytecode. So now we're just generating a repeating string, running executable in R2 with the generated string, and then we can see in clear text now the address. So let's just make the computer understand it too. So I know that Python is kind of good at grabbing stuff, right? So we could split it on spaces. I don't think that's good because we're looking for the adder the position of adder equal. So we want to Python find and string, and it's from the start. So we actually know exactly if we find the position. Find. Search for a substring. A string. Oh, this is probably too complicated. I mean, I just want substring starting this and substring. Yeah. So we only need this, and that's all we need. Let's go back and grab the basic example. Yeah, so this is just find. So, I'm selecting stuff in that one instead of this. Instead of this, so receive line. Dot find. And equals. And then we're gonna get a bit of this, but what we don't know yet, because I have to find. I can just do the square parenthesis and add numbers, but I want to like, is there some intelligence in this? We'll start and end parameters. So just find substring. Yeah. Is there a substring thingy in Python? Because there should be something better, right? So I guess this is what I didn't click before. Yeah, but I want like smarter thingy. I guess I'll have to calculate myself. So first of all, we're gonna. Oh gosh, I'm clicking on the wrong screen again. Again. So we're gonna print the received line find address, and we're gonna print let's comment this out so it doesn't have to have a value. Well, I guess it can have this. It's okay. Doesn't have to be the correct one. Print received line square parenthesis. Let's call this position. Let's just do pos equals. And let's do this like I don't remember. I think you do 2 colons and did I get something in my search? I did. Slice. Built-in slice. Want to know what I have left. End string 15 and 19. Oh, this is ugly. So this is so manual. I want to have a search element in there. So 2 explicit positions. Oh. Number that begins at after 6 and ends has length 9. When you can extract the count number this way. Yeah, this is better. So, we know the length, right? So, we want right. So we're getting this in text format too. Let's do one thing at a time. So let's say that our first one is then pos, right? And the length is but it's not pos, it's pos plus the length of the word is 1, 2, 3, 4, 5. This is what I think it's like. Not pretty. It's not pretty. I would like to have the end of adverb equals. Right? And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's put this as this, and it will be the wrong type. And let's do that. Of course it won't look like this. This is just me testing. So process involved keyword argument. Yeah, so it can't even do this. So pass. I had to try. So copy, delete, paste, and run. So we got the right thing, and I'm almost sad because it's not pretty code. We don't need a print pass. We could put it in here, right? I can have this short, ugly pass variable name in there. It's okay. So now we need to convert this to an int, I guess. So the EIP position here at the end, we're not printing it or doing anything with it. So I'm a bit worried that this doesn't complain. No, it wants a string. It wants a string. Let's look at cyclic finds. It wants a string? No, it doesn't want a string. So let's make this a string. Right? And let's run it. Yeah, so this is what we should get. Expected a 4-byte sequence you gave. Unless you specified cyclic. You probably just want to. Yeah. So it definitely is supposed to be the data. And if we do, well, this is also 0x, right? Let's run it by the way. 116 is the right reply. So what we want this other one to do is to get the reply. Print EIP. Nothing. Yeah, it's so slow. It's very slow. And print should be 116. So I'm kind of assuming this won't work because it's the wrong type. It's -1, right? Because we have a string there. So it's failed. We need to see, does it work to end this, right? So it will definitely fit in the data type. The problem is just, will it understand the syntax 0x, right? Will the function int do that? Int with base 10. Yeah, so it understood what it was, but it couldn't convert it. So we need to find a Python function for this. Python convert OX to int. Yeah, so we want this to this. Int 16. Oh, we just say the base? Prefix guessing behavior with 0. You're coming again. So my kid's knocking again. Let's just do comma 0. So it did understand it. It was just a bit off. So I'm gonna go check what my kid wants. So, just a bit of Wi-Fi debugging. So we got the right one, and it works. So now we have this automated. If we use another executable, this will still work, probably, right? Because we're sending the start program. We're waiting for a dead. And we can activate to see what on earth is happening if we want to. This line is bad, and this is not necessary. So, we need to do this. Print. Finding the IP position using R2 output of crash address. Print crash address. Let's make this prettier. And it's text, so we don't have to mess about. So, running, right, I forgot the \n. So, better looking. Yeah, I think I like this. Running executable R2 with a generate string, buffer overflow, crash address. Oh, let's put a column there. And then we're doing finding AP position using R2 output of crash address. I guess we should say AP position here, right? AP position. So now is the next cool step. Generating payload. And we can delete this. Quitting R2. So I'm tired. I'm starting to get tired. I've been streaming for 8 hours and 9 minutes. Yeah. I know when I do this kind of thing on stream, there's not a lot of people. It's sad. Not that there's millions of people ever, but still. This is not the most popular thing. It's so fun. How can people not like it? I don't get it. Another pwntools cheat sheet, or is it the same one? That's another one, right? Oopsie. Yeah, we have that up already. We did that. Now this looks cool, but we not checking it already. Did that. Did that. Fix that. There's a basic one left. Next up, we already did. We just didn't put it in this file. So, it's kind of easy just to copy this and cut away what we don't want. So, print, generating a payload to run as input to a suid binary. It will work on others too, of course, right? So it's not that it has to. Well, yeah, it won't. User ID 1001, right? Wasn't it? Ooh. We didn't set the ID. We didn't set the ID. Let's check this out because there's an error in here. I'm assuming we might send it here or something. There needs to be an argument for this. User. And it became used. User. So when we run the command prompt version of this, we give it an argument. And I'm kind of assuming we'll just do the same. Why am I not searching? Because I have one thing there. UID equals, yeah. So I assume this. But it's better to check it out, right? Args UID. So the only thing I was really mostly curious about is what format does it want it as a text string, right? Well, let's assume text string, and I think it was 1001. There are 3 users, and we are 1002, and we want to become 1001. Now let's confirm this in our notes. So, I might have done an example in here. Yeah, 1001, because I did the wrong one first. And also this is AMB64, which is wrong, because I realized later that's not what we want. We want I386. Yeah, and here's the full one. So this is we've had this forever. But now I want to make it automatic, right? The point of this is to learn pwntools. And I don't want to finish the box because then, it's not the same drive to finish it, right? It's a bit... Also, there's no flag or anything. You could just click the button, right? So I'm not clicking the button until I'm done. So we don't want this. And we don't want to print this under code now, but we can leave it in here. The architecture, and let's put those there. Print as, and this is the same. So this is full payload would be generating a shellcode. To for a series binary user ID. That's good enough. It could be there. So full payload would be, and then we start with our primary multiplication here, right? 8 times, I'm looking for the name, EAP position. So EAP position, payload equals, and also here we need shellcode equals so EAP position, and let's be this so we can plus everything, because this will be bytes format. A times EAP position. Right. There's more stuff to do. Plus address. And where do we want to put that? Why do we usually use it late? We'd also not checked anything. So let's add a badgers and a address here, right? And actually the other way around. I'm so tired. This will be tough to automate. But let's do it, right? We can do everything. Oh my god, how could you do this? I have no idea at all. But that's the fun of this. So I'm not gonna. I don't have energy for all of this today. And also the bad shards. Right, so let's put a question mark on that. And we can just test our payload, right? Oh my god. Let's skip these. We have the address of the code from the start. It is in this info. So we have the base address for the whole thing. I think we can find like any address. We have like function addresses. We have all those things. So if we do this tiny thing, will it fit? I don't think it will fit, will it? 116. And just point it back, I'm thinking. But also, I mean, jump ESP. I think there was something for finding instructions. Equals. Let's do the whole thing. Where we I'm not sure if this even exists, you know, or something. Oh, wrong key. Yeah, I'm getting tired. I'm thinking, should I do nothing and play a bit of games before I stop? So let's see.
I know all these guys appreciate it. I know.
Oops. Yeah, I was like thinking. So we could do soldering too, but maybe I'm too tired for that, you know. So I just started Twitch here. So like I'm thinking here. So what should we just continue maybe?
Communication
I
is
think
something that's
my god, why did I click that again? So I'm thinking why Where did I see that? That's the question. So, oh, you're on the wrong screen. So I could do it text-based from just grabbing the code, disassembled code from pwntools, but I'm thinking it might already have a function to see if there's such a thing, but I don't think there will be. So how many bytes of code do we have really? So let's tab over here, and did I even run it? Because I have not finished stuff. This is not runnable, and also yeah, let's comment that, make a new copy, paste that, and think we're just gonna add shellcode. So let's check the length of the shellcode too. So print shellcode. Let's actually do length first. Print. I could just copy that. And then we do length on this. And then we do str on this. So we can put it in with a string, explaining what it does. And shell code length plus bytes, and I'm gonna run it 50. Oh. Yeah, I didn't think here. There needs to be colon space and str. So how many changes did I do between one? Shellcode is 57, so that's not long. Length. Let's actually make a little bit of a space there. Shellcode length. Oh, what's that? So, shellcode length. Well, right. Why did I do that? We don't want the backslash in there, but we want one here, and we want a the, because it sounds very odd otherwise. So, shellcode length. Oh right, actually one line before that. Sorry. This is the one I want to. Of course, should know that. It's just a few lines, because the shellcode is several lines. Shellcode length, should we put a length afterwards, maybe? I think it will look better. I'm generating shellcode, and then we get the shellcode, and then we get the length of it. And the file payload would be and we need also the address there at least. And the address should be a string, I guess. We should output this as a string. And now I suddenly know why we had some of those functions here. A utility, I guess. So we had like pack here with this kind of thing, right? But it's still just a number. Yeah, we don't need that. We more need what we already did, right? Not that I remember what on earth I did. Yeah, my brain is going funny. It is like 1:14 a.m. I have to check back and see what I did. Yeah, int crash address 0. Actually, I don't want it to be that way. I want it to be a number from the start. So there, now it will be. So it's so slow though, the squiggly stay so long, so I think I wrote something wrong. But my eyes are starting to hurt a bit. And I think it's a little bright light, you know, I have kind of bright light in here. So what you think? Should we do one thing more, or should I like go gaming? It's Friday night after all. I need to like relax. This is fun, but I'm starting to get a slight headache too. I think it's light. But I don't exactly remember. So, find instruction. Assembler functions. CPP. So we've already Make elf from assembly. That's cool. That's so cool. Internal functions. Yeah, so this wasn't it. So we already knew this. Yeah. My script also automatically disassembles all the ones. Elf info. This one. Only the functions not starting with underscore automatically. And we know we can get the base address also. And when we run this, let's actually move this code into here, and I'm gonna put it here, and we're gonna remove the F bit because all these things are in there, right? And when we run this now, it's gonna not do a thing because it doesn't know what E is. Does it? We don't have an E. We do have a IO. Why is it called IO? So, IO process. Yeah, I guess I have to do the E. The E bit, we need the E bit. So, I'm assuming that now when I've disabled everything with errors, I'm not gonna get any output from this. Because that was a bit annoying that it output stuff. So we have a file name. It's called executable in this one, right? So executable in there. And then we just reference E. And this is an automatic finding thing. And now we're gonna run it again. We're gonna get all the instructions out with the addresses. So I'm just looking here. So I'm thinking that if there were any interesting instructions that we could use for jumping here. Otherwise we'll just do the check in the memory what memory address stuff house. And I'm too tired. But we started on the next step, right? So dress for yeah, I can't find words for yeah. Let's say the same thing I did down there. GMPSP or something. Or just the address we're on when writing. Yes, I'm gonna switch theme. But I'm also gonna switch something else. So let's hop over and start my second OBS and hope that it doesn't crash. And let's see if I can do a bit of this. I'm a bit tired though. But it's almost 9 hours streaming, and it's all been this kind of thing. And I've learned a lot. So OBS wants to update. Yeah, so if you're on YouTube, I have a second channel, and I might we're gonna look a bit more on this, I'm thinking. Let's copy this over to so making a script Python, and this is what it will look like in here. So it's not that long, is it? It might be that long. Not finished. Not finished. So I'm gonna close few things down. So we gonna let's see here. So speaker bot is for YouTube only. And oops. And this thing. And then we have what happened? Oh, I'm like, where is the window? And I have it right in front of me. So, let's see here. Yeah, I'm gonna this will be kind of odd. I could test this thing out. So the stream together function, haven't really used it a lot, but maybe I will. So what do you think? Should I continue something like this? Should I play with PVs? So my brain isn't really that on anymore, right? I'm just gonna close a few windows down. So this will be finished when I have learned enough, or when our script is finished, right? Then it will be finished. Because it could be easily done by not planned, not automatic, not reusable ways. But now I'm making it very thought through. And yeah. The first one was a Windows executable, and then we got to the box and, oh, this is odd. Oh, it's wine. Let's try a Linux exploit on the same thing. Oh, it worked fine. We had a nice Linux prompt. Checking stuff. Oh, we have sudo on this binary that we can't access. We need to be another user. This is probably a suid. Found the suid with other user, and that's what we're looking for buffer. Well, we found the buffer overflow, but we're still looking at the exact thing to send it. It's really just the last bit that are left now in the script. Otherwise, it's doing it automatically, and that I think is kind of cool. So I'm thinking, let's do this. And it is updating. Of course it's updating. What should we hub up? Hub up something that's not so ugly as my background. Where did the updating thingy go? We have StreamerBot up still. Oh, it's loading user data. I'm thinking it will probably explode in volume too. And I'm gonna go low on the light now. So let's see, lights. I'm gonna grab some nicer lights here, so my eyes won't die. So some nicer lights. And I'm gonna alright, I have another one, I think. No? Let's modify this one.
FixerBot says.
New follower HFS Comster.
Let's go
Less than 3.
Play some games. I'm gonna actually do something else. I'm gonna raid myself if it's possible. We'll see. Yeah, so I'm currently streaming on the second channel too. That's called Fixit42 and mine, and we're gonna raid that account because I don't want to mix cybersecurity and games and stuff on the same one. So we have 2 OBS up here now, 2 OBSs. This can continue doing stuff while we raid. So very welcome in. And I've been doing for 9 hours in 9 hours exactly streaming cybersecurity. Now we're gonna go relaxing a bit, right? Yeah, we still got a purple light back there. Should we switch it to red too? I can't even see what's red. That's not red.
Skillmster says. Hello equals.
So, what do you think, guys? We currently streaming on 2 channels. We could play the test the stream together thingy. I did close my Firefox though. So, HFS Kilmster, welcome in. I guess I'll do a raid, and I have to also check the what's it called? Streamer. No, oh my god. So I'm really, really, really not in the best of shapes, right? Whatever. I've been streaming for 9 hours. Brain material. Now we're gonna relax. So, just 1 second. I'll be done. I'll just type a raid somewhere here. Raid. Fix it. 42. Unwinding. No G on land. That's it. Fix it for to unwind. That should be right. Let's see if we get the right raid logo. Yeah. So, you're welcome to come with me and raid myself and play some games because I don't want to do it on this channel. So, let's see here. It's going. And also, let's send the for YouTube along, right? You can't see. I know you're there, YouTube. We're gonna send you a link. I'm gonna send you a link to the channel. So let's see here. There, and then I have YouTube chat. And I'm gonna manage to type the URL there. Unwinding. There you go. That's the URL for the other Twitch stream channel. And I have like 6 followers or something. So I haven't been doing this a lot of times. Actually, let's play with my little dude here. So, welcome in. The camera will pop over soon. I'm gonna stop streaming on the main channel